Wow.
Kelvin in the
That's pretty hot.
That's pretty hot.
And one of the things that's extremely important today is sun safety in terms of viewing the eclipse. And so we have Kevin Boucher, who's inside Saluki Stadium, to learn more how we can view the sun safely. Take it away, Kevin.
All right, thank you so much, Chris. You know what? This eclipse it's amazing. It's a little bit dark, but it's doing pretty good. What do you think, Bob?
It's great, but it's pretty light. Kevin, what's on your face here? You got your eclipse glasses.
Oh, I'm not supposed to put them on now.
Not yet.
Oh, okay. Introduce yourself to the world.
I'm sorry, I'm just kind of skippy happy.
Thanks, Kevin. I'm Bob Baer. I'm with SAU Carbondale, and we're out here at Saluki Stadium. We're going to talk about eclipse, solar eclipse safety for just a few minutes.
Okay, and again, briefly, I've been talking to it till I'm blue in the face. You have to wear special glasses. Welder's glasses or extra dark glasses will not do the trick, correct? And you're the expert more than I am, right?
Well, thank you, Kevin. And that's right. And the glasses, as you notice, you put them on ahead of time, you can see nothing until you look at the sun. And looking at the sun, beautiful. And yeah, we've got some welder's glasses. We've got some other things to demonstrate here.
Please do. And who are our young ladies here?
We've got two Girl Scouts here with us today, and I'm going to let them introduce themselves.
I'm Leah Conley. And I'm Kaylee Kitchen.
Nice to meet you both. So, I see you have some glasses here. You have quite the collection.
I also have more down there.
And you've got this more down there. Why don't we talk about the glasses first?
Yeah, please.
So with the glasses, the first thing you do, and we can do this together, right? We put on the glasses and then we look at the sun. So you can hold them up in front of your face. You put them right in front of your own glasses if you have glasses, and just check it out. And it's pretty cool. It looks a little yellow, right? Now I've looked at it before with something else. The yellow binoculars, please. And these are called sunoculars. They're made by Lunt Solar Systems, and with these you can actually see sunspots. They're a little hard to use, but we're going to give this a try because, Leah, you told me that you've used binoculars before. So you put them in front of your eyes, and you look up, and you focus them, and I'm going to let you try. So go ahead and get a free hand there. Put them in front of your eyes and look at the sun. It takes a little while to find it.
yet.
You know where the sun's at? Tell us if you find it.
They have just hit what is called first contact.
Can you find it yet? What do you see?
I see like a big yellow dot.
Do you see any little black spots?
So the eclipse
A few.
Those little black spots are sunspots, and we're going to get a better view of those a little later from the Lunt Sun Lab right out front. So should we go ahead and check out some of the others?
Yeah, we've got a roughly 4.5 minutes to go, so let's look at what else we have.
all across human history. And we're going to do that.
Let's bring in the goggles, and you can just hand that back to this gentleman here.
Carbondale, the first one, Dr. Roberto Barrios is
Have you ever used goggles before? So you can hold them up to your face, or you can put them on, and we'll bring in the welding helmet too.
Now is Dr. Grant Miller.
Thank you.
And again, now this looks like any neighborhood store welding helmet, but this is specially darkened, correct?
It is. This has number 14 welder's glass in it. This is safe to look directly at the sun with, which is the same glass that's in the goggles right here. So you can put this on, look through it, and check out the sun. You want to take this one? Okay, go ahead, Leah.
I'm going to go around on this other side just like last time.
Tell us what you think.
What do you?
It kind of looks the same, except there's some UV rays coming out from it. Neon.
Can you repeat that for us, ma'am?
It's a bright neon yellow almost.
Well, it looked kind of green to me, but the welder's glass is safe. You see a little bit of haze around it just because we've got a tiny bit of haze up there, so you're seeing some of the very, very light clouds that we have, and you're getting a little bit of dispersion off of the welder's glass as well. But you girls brought something to show us, didn't you? Okay.
Again, we are just off the 30-yard line at Saluki Stadium. Bob Baer with the SIU Physics Department, and we have two Girl Scouts, and they've got something else really special.
So It looks like you have a pinhole viewer, but it's not a pinhole viewer, is it? So you want to tell Kevin what this is?
So it's basically like you don't look right up at the sun, but you like look at the light, and it's like rainbow kind of, because this makes it look like there's like 9 holes around it, and so then all like the rainbow lights.
Yeah, we made it out of an old cookie box for Girl Scouts.
Do you have any extra tag-alongs? Can I place my order right now? Thin Mints are my favorite.
It's not cookie season.
Yeah,
It's not cookie time, it's Eclipse time.
they would already be gone.
When I was talking to you ladies earlier, you have an interest in science, right? What did you tell me earlier? What would you like to study?
Robotics. I really like robots and programming a lot. And me and Leo are both on a robotics team. So
And what about you, ma'am?
same basically as her. We're on the same robotics team. We like she wants to be an. What do you want to be?
I want to like program a lot of robots for NASA. I would really like to, experience like robots and stuff and their high-tech programming a lot. So I thought that was cool.
And I want to help navigate the space shuttles at NASA.
Excellent. Well, I can already tell after visiting with you, you girls are very excited and you're very well spoken. And I just think the stars for you. You're going to do anything you want. Thanks for coming out.
Thank you. Thank you.
Boy, Bob, our future is in very good hands, don't you think?
This is awesome, Kevin. And I wanted to take a moment to explain what it was that they have there. They have a spectrometer that they've made, and it's not for directly looking at the sun, but they demonstrate it properly. They look at light, just light on the ground, and it shows you a rainbow. It shows you a rainbow because the sunlight is just pure white light. Now, the other thing that's really cool that we can do coming up, and I might even have them demonstrate this again with me, is you can do pinhole projections. And this is following first contact. When you do a pinhole projection, you're going to see a shadow of the sun on the ground.
We can see that right here. And also in the brief time, I think in less than a minute we have, someone told me it will be like an amazing sunset, but 360 degrees.
It will be. So 360 degrees around you during totality. So after 1:20:08 here in the stadium, look for that sunset all around you, especially the people in the upper rows here in the stadium or the roof.
Excellent. Can't wait for that. This is Kevin Boucher along with Bob Bear at the SIU Physics Department. We are inside the stadium where we will soon be surrounded by 15,000 people. And right now we're going to see a very fascinating video. NASA scientist Holly Gilbert will teach us about heliophysics.
So Holly, what's the role of the Heliophysics Science Division at NASA?
Heliophysics science basically includes studying what happens on the sun, how that impacts us here at the Earth in our near space environment, how it impacts other planets and the space environment around them, and also all the way out to the domain of the sun, to the edge of the solar system called the heliosphere. So it encompasses all of that and how the sun is connected specifically with the Earth.
Right. So you're studying each research or each component from the Earth all the way to the sun and beyond.
Correct. We have a lab that studies the solar physics part, what's happening on the sun, how that happens. We have a geospace lab studying all the impacts here at Earth. We also have a heliospheric physics lab, which studies basically the stuff in between, the solar wind, and how that reaches all the way past Pluto.
And what are some of the kinds of technologies that you're using to study the sun? I'm assuming it's a lot of it's satellites?
We have a lot of satellites. We have actually 18 operating missions to study all of heliophysics, not just the sun. But in order to study the sun, we have remote sensing observations where we can look to see where solar storms are originating, how the sun is behaving, how it goes through its different cycles of solar max and solar min, lots of activity.
I mean, it seems like with 18 missions, just satellite missions, plus you have ground-based observations you do, and I'm sure there's some aircraft observations that you use.
We have ground-based observations that we collaborate with. There's a series of them around the world. Okay. We also shoot off sounding rockets and balloons to take measurements that from an easier place, but mostly we depend on satellite observations. However, we also depend on sophisticated models. Okay. So it's not just about the observations and the data.
Right.
We really need modeling to fully understand how that system works.
So when you look at that Sun-Earth connection as a system, are you trying to come up with, let's say, the holy grail of one model that can predict everything, or?
It would be great if we did have one model that
Right.
did connect all that. Right now we don't. And you're right, it would be sort of the holy grail to come up with a model that connects all that. Right now we have models that look at the dynamo, what's going on in the sun, and even those aren't completely accurate. Then we have models that determine how stuff travels between the sun and the earth. We have models that determine how that impacts the magnetosphere, the ionosphere, which is kind of a system in itself.
Right.
So energy gets transferred from the magnetosphere to the ionosphere and vice versa. So it's very complicated, and that's why it's very tough to have one model that covers that whole
And that's why you
domain.
need so many missions to study the
Right,
different aspects of it.
Exactly.
Since you started your career as a solar scientist here at NASA, what have been some of the biggest discoveries or greatest discoveries about the Sun-Earth connection?
There have been multiple discoveries throughout the last 50 years especially, and even since I've been here at Goddard, but some of the most important ones were the fact that there's a solar wind, that the sun is basically blowing out its outer atmosphere all the time, and so that we're embedded in that. We get impacted by that, and that's part of the connection. We still have mysteries we don't know, like why is the corona, the outer layer, the atmosphere so hot?
Right.
How is that energy transferred? And then we have mysteries about how the energy that reaches us here at the Earth, how does that impact the magnetosphere, and how does that then get transferred down to the layers of the atmosphere? So there have been tons of discoveries, but we still have so many that we still need to answer.
Now, if you remember years ago, I think you invited us on a cruise ship.
That's right.
You were actually going to go and visit an eclipse.
I did.
Or actually not visit, but you're actually going to experience an eclipse from a cruise ship.
Yes, it was amazing.
So tell us that experience, because we never caught up with you afterwards to share
right.
that experience.
It was my first total solar eclipse, which, you know, as a solar physicist was a little strange, but it was amazing. And from seeing it on the boat was really incredible because you didn't have any landscape to get in the way. You see the shadow racing towards you on the ocean. When you're surrounded by other people that are just in awe, that's part of the experience as well. But being on the ocean was definitely very eerie, and it's like turning to night. And of course, the people are all ooh and ah, so you get that experience.
Right.
But it was very, I guess, eerie is really the word I can use. It's hard to describe in words.
Hi, this is Franklin Fitzgerald from NASA Edge, and I'm in front of the Lunt Solar Systems Sun Lab here in the Science Demonstration Area at Southern Illinois University. I'm here with optical design engineer Brian Stevens, and he's going to tell us a little bit about the telescopes and cameras used to bring us the images that we've been seeing today for the solar eclipse. How you doing, Brian?
Doing great, Franklin. How you doing?
Pretty good. Now tell us a little bit about the telescopes that you're using today to bring us these awesome images of the sun.
Well, actually, we're using right now 3 different telescopes, one H-alpha, one calcium K, and one set up for white light. We also have another setup set for totality, but that's actually more of a lens setup on a red camera. What the system actually runs through actually bounces off the heliostat over here, comes through the wall, and hits all the lenses on the optical table. The hydrogen alpha is what usually most people will see as the yellow, orange, red colors that they'll see with the prominences coming off the edge and some nice flared areas and possibly some high activity and some sunspots on the surface, and it's usually what most people are excited about and stuff like that. Calcium K is a little more different. It's more towards the UV. It's more the purple color that you're seeing there. You get to see a lot more of the plage on the surface, and the sunspots come out really nice on that as well. We got quite a grouping of sunspots in 2 different locations today, so it's really exciting to be keeping an eye on that one right there. And then the white light, of course, is just a general. Basically, it's essentially the same as what almost everybody's looking at through their glasses, just on a bigger scale, and we can actually get a little bit more in-depth and detail on that with the sunspots than they can with their glasses, and maybe some binoculars out there in the general public.
Now, those telescopes are encased with the cinema cameras inside of the Sun Lab, but the heliostat is on the outside, and that is the one thing that everybody can see. Tell everybody about the heliostat and how it works.
Oh, okay. The heliostat actually is an 18-inch mirror that's actually suspended in a fork mount that actually is designed to track the sun across the sky and actually point it in the same general direction, i.e. on the same spot over the entire course of the day. It has some fluctuations. Sometimes it's not always perfect, but it's doing a good, pretty good job right now at this moment. Bringing the light in onto the table so we can stay inside there with all the computer gear and all the nice red cameras, keeping everybody informed with the 6K.
Now, it's reflecting the sun, but why use a reflector versus using the telescopes to look directly at the sun? Is it so that it's in constant contact, or what? Because the mirror is quite a distance away from the actual telescopes.
The mirror is a distance away from the telescopes. It doesn't really need to be quite as far as it is, but if the location permitted us to go that far, gets us a little bit better angle coming towards the table. We have ability to move the telescopes individually on the table as well, so we can line everything up when it all comes time. So it works out well.
That is awesome. Now, tell us a little bit about the resolution. We are actually streaming in 1080p Full HD, but the cameras we're using are 6K. How often do you get to shoot the sun in that high of a resolution?
Most people don't get to shoot the sun in 6K. It's an odd situation. It's working out terrifically, and we're very happy with the red cameras, and they've been working spectacularly. It's a lot more information than anybody's even seeing out there with the compression that's brought down to 1080. Some is lost, but it still looks absolutely terrific. I was watching the feed in there for a moment there just to see how things were going, and it looks really wonderful.
And we're efforting that fourth camera to see the corona during the total solar eclipse, right?
Yeah, we're kind of winging that one, so we're going to have a few moments of sheer panic inside, and then we'll actually probably get everything lined up and rolling pretty well, and we'll be able to give the 6K image of that as well.
Now, Brian, this is my first total solar eclipse. How many eclipses have you witnessed in your lifetime?
I've seen two, but not. This is my first total, so this is a newbie for me too. So. I'm looking forward to it, hoping Mother Nature stays with us here and we can see the whole thing. It'd be awesome.
Now, how awesome is it to see all these people around here? For the whole week we've been here setting up, getting ready for the total solar eclipse, and it's been pretty light because the spectacle of the total solar eclipse didn't happen until today. Now that we're here, there are thousands of people walking around. What are your feelings on what you're witnessing today?
Honestly, yesterday I was wondering if there was going to be this many people, and now we are in a swarm of people. There's a lot of individuals walking around here, much more so than I thought would be. So, flabbergasting. There's a lot of people here. They're everywhere.
Right now I'm looking up in the sky. It's no cloud cover. The heat is just beaming down. It's pretty warm out here. Brian is actually going to get back in the Sun Lab, work on processing the images that we're seeing, and he's going to come back with us a little bit later and give us his thoughts on the solar eclipse. But until then, we'll send it back to the main stage with Blair.
Thanks, Franklin. Welcome back. It's great to be here with Troy Klein, talking about social media.
All right. I think I have a crowd. I have a fan base,
yeah.
Blair.
Troy has his own fan base. This has nothing to do with the show. It's just
awesome.
Having Troy.
Awesome. Love you guys. Wow.
So anyway, in addition to the great participation we have here, we're also doing some social media things. What do you have in store for us today,
Blair,
Troy?
it's just the United States is igniting on social media right now, and it's just hard to explain the excitement. You can feel it in the air while we're here.
Very exciting.
And we're helping people connect to us in multiple ways through social media right now. And one of the ways is through Facebook. We have the NASA Edge Facebook account that you can go to. You can post questions there. You can also go to Twitter, and you can post your questions there. Now, one of the best ways to post questions is just by using a simple hashtag, which is just basically hashtag NASA Edge with the letter Q. And we have people, SIU volunteers, who are helping us right now. And they're basically going to give you they're going to keep an eye on all of your questions and hand them off to the talent that's here on set. And you'll be together.
That's what I love. We're going to try to answer some of the questions here on set. But Troy's team is actually going to be doing that throughout the day and even
Throughout
beyond,
the day.
right? Even
and beyond, that's right. We actually have talent graphics is what we're calling them. We have all of our subject matter experts who are on the show today. And just moments before each one of them appears on the show, look at the NASA Edge Facebook and Twitter feeds and channels, and you'll be able to see the graphic asking you to ask that person a specific question. And we, again, will be looking for those questions. And if you're lucky, you'll hear your question asked live on the show.
Well, now, speaking of that, we also have some Twitter questions that we want to specifically ask, right?
We do. Throughout the course of the show, we'll have 3 specific questions that are fun, and we really want your engagement interaction with this. Our first question is called Eclipse in 6. So basically, let us know what the eclipse means to you in 6 words. And with hashtag Eclipse in the number 6. And we're going to come back in just a little while and we'll give you the results. Now, some of the samples, had a few people give us a few. One says, amazing, stunning, excited, great, mouth-dropping. I didn't count that, but I think it's 6 words.
Okay.
Now, the next one I saw was wonder, excitement, beauty, intrigue, and celestial darkness. And I was going to say that reminded me of you for some reason, and I'm not sure what that was.
Yeah, it makes me nervous too, but you never know, right?
I know it.
I just tried to quickly formulate one for me, Troy, and I'm thinking, what about note to self? Use Eclipse glasses.
That's perfect.
Right?
That's perfect. Eclipse glasses is the magic word.
Yeah, and I deliberately did not say sunglasses because there's real confusion out there.
That's
over that, right?
That's right. Yeah, some people are trying to figure out just different wild ways to view the eclipse, but the only safe way to do it is with ISO certified glasses or with something I have with me. You can actually watch partiality the entire time with Eclipse pinhole projectors.
Nice.
This is one you can go to the NASA website, eclipse2017.nasa.gov, and you'll be able to download paper or 3D printable pinhole projectors, which thousands of people have done. You basically just hold it up to the ground, let the sun project an eclipse onto the ground, and you can see a beautiful eclipse and keep an eye on partiality.
Now, I noticed something interesting about that viewer that you have there. That you said that there's a hole in the center.
Oh, that's right.
But then there's also a hole over near a capital, and it's it's not a hole, it's a star. How will that work?
Well, actually, this is something that would be great for people to ask questions about on social media, because
we're not going to tell you.
We're not going to tell you. I'm the teacher in me. Wants you to figure it out. But it actually was done on purpose, because we have a star shape where the capital is in our pinholes and a normal round pinhole in the center. But what happens is when you start projecting the eclipse onto the ground with the sun projecting that eclipse onto the ground, your projection in both cases will be perfectly round eclipses. They won't be in the shapes of stars or squares, so it really doesn't matter the shape of the pinhole. It just has to be small enough with something large enough to project it.
Okay, can I challenge you a little bit on
this?
this?
Sure.
Okay,
Let's see what happens.
Well, I mean, you can only test this with an eclipse, right?
That's right. That's right.
So how have you verified this star-shaped miracle? Because, I mean, I'm doubting it, right? I'm calling me a skeptic. I'm a little bit skeptical. I want to know, how do you know that all?
You know, I have to be honest with you. I was a skeptic too.
Oh, okay. That makes sense.
But then I went to an eclipse last year that I'll talk about in the show in Micronesia, and Eric Christian, one of our scientists, and I tested out little pinholes on 3D printed cards to see what size was the best size for projection. We found out 5 millimeter at about 5 millimeter hole, about 4 feet away from the ground, projects a beautiful, perfect eclipse on the ground. And you can use your fingers, crisscross your fingers. You can use branches from trees. Anything that projects a pinhole will work.
Now, that's interesting you talked about the trees, because I've actually seen some images in magazines and stuff where they're on the web where you see this nice, wonderful pattern as a result of trees. When you've seen eclipses before, I mean, aren't you tempted just to I mean, because it seems like there's spectacle everywhere, right?
There really is.
I mean, do you have time to catch a glimpse of all of
them?
You
do. You have about a good hour or more before and after totality to be able to watch all these pinhole projections underneath trees and on the ground. So you have a lot of time to play with your pinhole projectors. You can actually take a Ritz cracker and project a pinhole through a hole in the pinhole of a Ritz cracker and get an eclipse on the ground.
Well, I couldn't do that because I'm so hungry right now.
Like
if I'm waiting for that eclipse, if it's eclipse or food, I'm consuming the cracker.
And it's so hot here in Carbondale, I feel like I'm sitting on the sun right now. It's kind of warm.
Well, that's sometimes that happens. Now,
it does.
You say you've actually seen an eclipse.
Yes, I have.
Right? So are you, tell us a little bit about that, because if you've received social media questions about it, you have the data point to respond to that.
Yeah, honestly, when I first saw the eclipse, before the eclipse, I was like, well, I've seen lunar eclipses, I've seen partial eclipses, probably similar in experience.
Looks like Troy's been a real eclipse traveler. I didn't know this about you.
I'm an eclipse chaser now. It's like, but it was the first one I saw was in Turkey, in Side, Turkey, and the next one was in Micronesia. And when the eclipse happened, it was about 85% coverage, as I could see with my pinhole projectors and my glasses. At about that moment, I noticed the sky around me started getting noticeably dark, and the temperature dropped about 10 degrees.
We could use it.
Oh my God, we're totally going to love that. And at that, right as the disk of the moon covered the sun, it was phenomenal. You're overwhelmed with an amazing feeling of being connected to the universe around you, because your vision is you're seeing things differently, the shadows are changing, the animals are acting differently.
Yeah. Yeah, we know
phenomenal.
about that. I do want to take a quick moment to say that welcome our friends from NASA TV who are joining us from Charleston. Hope they have clear skies there. We clearly are having clear weather here.
We're having clear weather.
A little bit of clouds, but easy to manage. Great to have you guys joining us. Now, like I said, you have time to check this out, to see these sort of eclipse views. What other strategies could you share with our fans to prepare for the eclipse?
Just to basically, when the eclipse happens, spend all of your time with all the different devices and pinhole projectors before and after totality. The biggest thing that I would recommend is when totality happens, unless you have a camera set up on automatic, don't miss a second of the event. Make sure you are looking at the eclipse. Now, one of the things, some people forget to take their eclipse glasses off during totality, and they miss the whole thing there because they think it's unsafe. But you're not actually looking at the sun during totality. You're looking at the backside of the moon, which is pretty dark.
Yeah.
I mean, it's the darkest blackness you've ever seen. And at that moment, you will see the corona of the sun just magically appear across the sky, and you'll see several stars today. I think we have and planets. So we have the potential to see 4 or 5, I believe, planets and stars.
Okay, but you have to be pretty strategic at that point, right?
Yeah.
Because that's during totality.
That's during
right?
totality.
So you got to get your solar experience, and then you got to swing your telescope around, or will you be seeing them with the naked eye?
You can see it with the naked eye during totality. Perfect. I recommend everybody look at it with the naked eye during totality.
Perfect.
But as soon as one bit of sunlight starts to come around the sun, trust me, it is super bright, and immediately put on those glasses and start using your pinhole projectors again.
That's a great point, and it's awesome because we're getting lots and lots of good science and good observational data to prepare everyone for how they can experience the events.
And you know something I have to tell you, we have a Flickr gallery that people are uploading many pictures to right now. We would recommend and highly recommend that you go to the eclipse2017.nasa.gov site. You'll see the Flickr links there, and these beautiful images that you're seeing right now are images that were already uploaded just over the last several days.
Well, what's interesting is it's not just photos from previous eclipses. We're seeing lots of artwork, lots of really creative work. I think that's spectacular and a great part of what's going on during
this
eclipse.
People of all ages are ready for this.
Yeah, it's fantastic. Well, I tell you what, Troy, thanks so much for coming on. When we come back later, you're going to share with us the results, right? And we're going to talk about that, right?
That's right.
And get more questions. Great. Well, right now we're going to go inside the stadium to Kevin Boucher, who's with Greg Guzik from the Louisiana Space Grant Consortium, and they're going to talk about this balloon launch that they're going to provide for us. So take it away, Kevin.
I sure will. Thank you very much, Blair. Again, we are standing on about the 30-yard line in Saluki Stadium, and of course the stadium is filling up. And with me now is Dr. Gregory Guzik. And introduce yourself. Who are you with?
So my name is Greg Guzik. I'm a professor of physics in the Department of Physics and Astronomy at Louisiana State University. More importantly, I'm actually the director of the Louisiana Space Grant Consortium.
Okay, now what is that consortium? Who is it composed of, and what is its mission?
So the National Space Grant College and Fellowship Program was established by Congress in 1987. It's a nationwide effort. Every state in the Union, plus Puerto Rico and Washington, D.C. has a consortium. And for this project, there's a team, a collection of about 55 student teams placed from Oregon to South Carolina who are going to fly balloon payloads very similar to what we're going to fly here from Saluki Stadium.
And when I think weather balloons, I have this image. I think of one of my old Time Life series of books the National Weather Service was launching a monstrous balloon. This balloon that in my memory was like 100 feet long, but yours are a little bit different. Can you talk about the structure of these balloons?
So these are normal balloons that the Weather Service actually uses, hence the name weather balloons. They're made out of latex, rubber. When they're fully inflated here on the ground, they're about 8 foot in diameter. And as we go up in the stratosphere, they'll expand to about 40 feet in diameter.
Okay. And if I believe right now on your television screen, I think you are actually seeing some data and video from these weather balloons. Oh, also earlier you told me you've been with LSU and ballooning for quite some time. Could you repeat that? That's important.
So I've been at Louisiana State University since 1983, so I've been there for a little while. And I've been involved with ballooning since 1991. We've launched balloons out of northern Manitoba. I've been to Antarctica about 4 times. That's probably our biggest balloon flight there. We had a 6,000-pound payload carried by a balloon that would basically fill Saluki Stadium, and that went up to 122,000 feet and circled Antarctica for about 15 days. We did that about 4 times. And then with this student program here, this is our 57th and 58th launch.
That's fascinating. You've been to Antarctica. That's the logo on your helmet. So what happened after it got up to 120,000 feet and you got a lot of data? What comes up has to go down. So what was the next step? Did you issue a command from the ground?
Yes, those balloons are sort of managed through the NASA Balloon Program Office and the Columbia Scientific Balloon Facility, and they have a whole infrastructure for radio transmitters and over-the-horizon telemetry and command and control. Actually, many of those Antarctic balloons are controlled from Palestine, Texas, no less. And so when we're at the end of the flight, they do issue a terminate, and that cuts the balloon away, and the whole system parachutes from the ground. Parachutes to the ground. Very similar to what we're going to do here, except we do that cut automatically.
Earlier I had heard, again, I am nowhere near the expert, I had heard that as you get up into the atmosphere, since the air is less dense, the balloon will swell up. So sometimes, can your balloon actually burst?
There is a chance that we would actually burst before we cut. We have a couple of, that's actually a feature in our parlance, so if our cut fails, we can always count on the burst, so we can start down. And we do have a connection in our payload so that if it does burst, it allows our parachute to still fill properly.
Okay, now the balloons, I assume they are filled with helium. Did I see 3 or 4 giant, or not giant, but 3 or 4 helium tanks about this tall?
So we use about maybe 1.5 cylinders of helium per balloon. So we've got 2 balloons for our program. There's a 3rd balloon here from another group. They use 1 cylinder. We use about 1.5. So there's about 5 cylinders of helium being used.
Yeah, whenever you started opening that valve and filling up the balloons, I could hear it loud and clear. And hopefully none of your students, I mean, this is serious business, so hopefully none of your students inhaled some and tried to do the Mickey Mouse voice, right?
Well, yeah, not yet. Sometimes when we're goofing around with a test flight or a tethered balloon, we might do a little bit of that, but that's not strongly encouraged because helium is not oxygen, and so we try to keep that to a minimum.
And now talk about the payloads. These fascinate me. They're instruments, and what kind of things do they measure? Air pressure, the amount of nitrogen, or what do they measure?
So we've got 1 balloon string. So the first balloon string that will be launched at 11:50 a.m. today has 3 student payloads. One is going to measure the intensity of light. A second is going to measure the intensity of ultraviolet radiation. And a 3rd one is going to measure the speed of sound. The other payload is the one that we're doing in coordination with the national program. This has 2 video payloads that are going to transmit in real time the view of the ground in HD video, and that's available through a site called Eclipse.stream.live, and anybody can tune to that website and follow all 55 teams from Oregon to South Carolina and their real-time transmissions, and hopefully these will work.
Now, you were here, you and your team, I should say, were here several months ago, and you did a test flight. It was kind of a drizzly day, but that was fairly successful, wasn't it? Did you get some good data earlier?
A lot of that test flight in June was to test all of our interfaces and our positioning of our satellites and of our satellite dishes, and talk with the SIU staff and make certain that everything is copacetic. And yeah, we had a good launch. We're able to track that and able to recover that fairly easily. So we test out radio communication, and so all of that was a good dress rehearsal.
That amazes me. And in just the rare few minutes that we have left, now the last part, you have a team, you do meticulous watching of the weather, try to find out where the balloon will come down, so you race to where the balloon is, you get all the instruments, and are there SD cards in the instruments with your data?
Several of those do have, in fact, most of the data is recorded on board. We have some video payloads that are recording on board. Even the real-time transmission records onto SD cards. And so, yeah, it's a good idea to get that recovery. But I'm sure we have the Southern University fire dogs with us from the Department of Forestry. They are expert in climbing trees and recovering parachutes from trees. And so I think we'll have a very good recovery.
And the last time I was here, you had a couple of small canoes or kayaks in your van. That just wasn't for hanging around and enjoying life, right?
That's correct. If we come down in water, then we'll have a chance to recover that too.
All right. Thank you very much. I'm going to let you go. And just in about, 10, 15 minutes, the balloon will be making its way up, correct?
It sure will. And so thank you very much for the interview, and give all of us a good luck, and hopefully everything will go well.
Good luck and Godspeed. Thank you.
Thank you.
That's Dr. Gregory Guzik with LSU. And if you have never seen one of these balloons go up to the stratosphere, you've got to watch it. It's amazing. I'm Kevin Boucher, part of the NASA Edge team, and broadcasting live from Saluki Stadium in Carbondale, Illinois. And now let's kick it back to the main stage with my colleagues. Or to tell
Well, we're coming back here on the main stage, but we want to focus on this calcium K imagery. I have Robert Walsh from the University of Central Lancashire from the UK and Lou Mayo on, but they're way more interested in what's going on in the sun than talking to me. So, guys, if you want to tell us what's going on here, that's fantastic.
Yeah, thank you very much, Blair. Yeah, this calcium K image it's just beautiful, isn't it, really? And it's showing us both the very active regions that are just above the disk center. That's been there for a few days now. We've been following that and seeing how it's been developing and the complex nature of it. But then also a new active region, a new magnetically strong region has just come on to the edge of the sun. And give you some idea of size and scale, you can fit 109 Earths across the diameter of that particular image, 1.3 million Earths in the volume of the star. And therefore those spots there you see are much, much bigger than our own planet. Wow. And that's rotating onto the sun just as we're about to start, of course, here, our time of total eclipse.
And so you're suggesting that actually that region that it's emerging, it's due because the sun is rotating.
Yeah, the sun actually does rotate. It takes about a month to make a rotation. The sun is quite an unusual object. It experiences something called differential rotation. That means that it rotates quicker at the equator than it does at the poles. About 25 days at the equator, nearly 30 days at the poles. This huge big ball of electrified gas is twisting in upon itself, and you can see that in the sunspots as they move across the solar disk, and they actually shift relative to where they are latitude-wise along the equator.
Thanks so much, Robert. I'm actually almost becoming hypnotized looking at this. It's easy to get lost in staring at some of this tremendous imagery that we're seeing. But I did want to get to some of our social media questions. People out there that are actually seeing some of the images and watching the show actually have some questions, and I thought it would be great if you guys could take a stab at them. I'm going to start here with this is a good one. What makes a good question is one that I would ask. It's how fast does the shadow travel across the Earth? That's from Tyler in Houston, Texas.
Yeah. From coast to coast, it's going to take about 3 hours for the what we call the umbral shadow to go from Oregon to South Carolina. And so it works out to about 1,500 miles an hour. Pretty fast.
Perfect. Now, this is a real complex question from my standpoint. So this is Hey NASA Edge. So they say, if the Earth rotates east to west, why does the eclipse move from west to east? And that's from Houseboat Joe on Twitter.
Yeah, a number of people have asked me that question as well. But really think of it that the Earth is rotating.
Yes.
But also the Moon is also rotating around the Earth. The Earth's rotation is around about 0.5 kilometer a second. But the moon's travel around our planet is about 1 kilometer a second. And therefore, it's like having two cars on a freeway. And you're pulling up, and you're slightly faster than the other car, so you pass that car. You can see the people in the car as you drive past. Essentially, the moon is driving past us, and the shadow is traveling across as it's traveling slightly faster. Therefore, it travels from the west to the east.
Perfect explanation. This is great. Thank you so much. And I hope Houseboat Joe appreciates that. But right now, we're going to go get the answers to more questions from our fans by going to Franklin, who's there with Sten Odenwald. Franklin.
Yes, I'm here with astronomer Sten Odenwald from the Goddard Space Flight Center. How you doing, Sten?
I'm doing just fine. Very excited.
Sten, total solar eclipse today. As an astronomer, how many total solar eclipses have you personally witnessed?
One, including this one.
Wow. So we're in the same boat. Okay. Check it. So we've received some questions all through the morning. Blair just had a few on stage, but we have one for you right now. And the question is, can you predict the shape of the corona? If so, how?
Yeah, we can sort of get a rough idea what the corona looks like, thanks to all the satellites that we have that are looking at the surface of the sun and the corona. We can pretty much get a good idea of what the corona is going to look like, but not in any great detail. And that's just a problem with we don't have enough data on what the corona does from hour to hour.
Now the corona is during a solar eclipse is actually pretty large. Can you tell us a little bit more about how it expands out from the disk?
Well, the bright part of the corona that you see is sort of closest to the sun, but the corona actually extends all the way out like 10 to 15 times the diameter of the sun in the sky. It's just so faint that you can't really see it with the human eye, but with satellites and other kinds of technology, you can sort of trace it all the way out.
Cool. I'm sorry, right here, my phone locked up. Second question is, if you are located in the path of totality, will the stars be visible?
Well, it's going to be kind of twilight time, so you shouldn't expect to see millions of stars, but you should probably expect to see some of the bright stars in the constellations, maybe a few dozen to 100. Especially the planets. There are going to be 4 planets out that will be quite spectacular. Venus to the far west is going to be the brightest planet you'll see. To the far on the east side, you'll see Jupiter, and sort of in between, you'll see Mars and Mercury rather faintly. You'll also see a very bright star called Regulus, rather close to the eclipse itself.
That is awesome. Now, Sten, I know that we can't call you an amateur astronomer.
I don't think so.
No, I know so. I know that's not the case. Are you going to be watching through your telescopes, or are you just going to grab a pair of glasses and gaze like the thousands and thousands here at SIU?
Yeah, you know, I've brought my cameras and I've got my tripod and all that, but you know, when push comes to shove at the end, I think I'm going to forsake all the technology and just do what people have done for 10,000 years, is just sort of take it all in and let the emotions flow.
That sounds great. Lou, it is 11:48. What does that mean in terms of the solar eclipse?
We're about 4 minutes away from the start of the eclipse, which we call first contact.
First contact coming up in around 4 minutes. Blair, back to you.
Thanks, Franklin. We have about a minute before we go to the balloon launch inside the stadium. I wanted to squeeze in one really important question because we've been getting this question a lot. Tell us a little bit about the kind of science we can do during an eclipse.
Well, one of the main things is to try and understand the science of the corona. And of course, we don't know why the corona is at the 1,000,000-degree temperatures that it actually is. So with an eclipse, we can go right down to the surface of the sun very nearly. We can see the corona that's usually hidden from our eyes. We try to understand the structure, how it's changing, and in many respects, the release of energy within that environment. And it's so hot here, I feel like I'm actually in the corona. It feels, you know, we're actually holistic astronomy here. We experience it in lots and lots of
Eclipse in 4D. It's just like being on the surface.
But, you know, to actually understand the corona is very important because all sun-like stars have their corona. We need to understand why the energy is released in the way it is.
All right, look, we're getting a call. We need to go inside the stadium right now. They're about to launch the balloon for the Louisiana Space Grant Consortium. So let's go to Kevin, who's standing by.
That is what's going to let that get safely down to the ground.
And all those instruments
strung out along there. Attached as well. That's a beautiful sight.
Okay, can you hear me okay, right?
Yes. Balloon launch in less than a minute. So
this is Kevin Boucher. Sorry about the little mix-up. I was too enthralled. I was too enthralled looking at this fantastic weather balloon that has just launched. You can probably see it behind me. It is pandemonium here, but it's good pandemonium. One of the weather balloons has launched, and with me is one of the team members. Introduce yourself to the entire world. No pressure.
Hi, my name is Colleen Fava. I'm the program manager for the Louisiana Space Grant Consortium based at LSU.
Okay, so just to kind of keep a scorecard for people if they're wondering, we talked to, I guess, the program director, Dr. Gregory Guzik. He is your boss.
Yes, he is my boss.
What exactly does your job entail with this consortium?
I manage the program, so I write grants and reports and organize students and keep them on track, and I do communications training.
Sounds like you do a lot of outreach as well, and it thrills my heart, and I'm sure it thrills your heart to see so many of these young people. You probably did not have to drag these young people kicking and screaming to do this help, did you?
No, we brought 4 institutions with us, and LSU is the home team, and so they were always coming, but we actually had a competition to figure out which other students we would bring, and we brought a team of 46 people.
Okay, and right behind you now, I had forgotten they're launching 2 balloons. Now, the first balloon, I think we have a video of the first balloon. Okay, we're getting ready to launch the second balloon.
Both of our balloons launched already. That's
okay.
The first balloon, another.
The first balloon, Colleen, that was launched, where is it right now? Maybe 2,000 feet, you think?
They go up about 1,000 feet a minute, so a few thousand's probably been a couple of minutes now.
Okay.
So.
There it goes. This other one has launched. It's a big yellow balloon filled with helium. And the next time we see this balloon, we'll be down on the ground. It'll have wonderful data. Can you tell us about what goes into studying the winds and the weather reports, trying to calculate where this will land so you can quickly retrieve it and get your data? That's a whole nother science.
Yeah, so I'm not an expert on it. I can just tell you that we do our predicts. We started our predicts months ago, doing them maybe every week or so, and then the last few weeks we've been doing predicts every single day. So we have a good idea. We think it'll go about 36 kilometers, about 22 miles due east, somewhere near Marion. So we'll have several chase vehicles kind of staged and ready to go. And I'm not sure if they decided to leave before or after totality, but we have some local people helping us to make sure we have access. And we're hoping, expecting to be a pretty easy recovery.
Now, will you actually be on the chase team yourself?
No, I'm not going to be on the chase team. I need to do logistics here on the ground. I have been on a chase, though, and it's very exciting.
Oh, I'm sure. Yeah, can you tell me about it? And please get as specific as you can. What are some of the most eventful ones? Like, has the balloon ever come down in
Pontchartrain River?
How did you know? You're not kidding me.
I'm not kidding you. We did have a landing in the Pontchartrain River, which was not a great recovery, but it was definitely better than landing in the airport, which we were afraid was going to happen.
Well, I was going to say I would rather land in an airport because the Pontchartrain River, you have the water that might damage some of your instruments, but you're the expert then, right?
I think we'd rather not interfere with air traffic control.
That's true. Landing in a Pontchartrain River, and I assume the alligators did not make a meal out of your several $1,000s worth of instruments?
We didn't recover that payload, but we have done water recoveries in the past, and we actually just invested in an inflatable kayak.
Okay. My producer just told me we are seeing first contact. Everybody, we have people putting on their glasses the first contact. We are seeing the first contact, and we've got about 4 minutes left. How many total solar eclipses have you seen, Colleen?
This is my first.
I assume you have your glasses. Feel free to go ahead and put your glasses on.
You want a pair?
Yes, please.
Your fingers together, you can make little spaces in between your fingers.
If you don't mind, I'm gonna.
You can project little images of the eclipses down onto the ground. So make sure you look down just as much as you look up.
Really see through them.
Also, if you
Right. Okay. My glasses are on. Are your glasses on too?
They are on.
Okay. And the sun, we are turning around. Would it be okay if I turn my back to the camera so I can see the sun? Oh, okay. I'm going to turn my back to the camera. Oh my gosh! There is a small bite starting in the sun. What are your comments?
I said that is gorgeous, isn't it?
That is fantastic. The total solar eclipse in Carbondale, Illinois has begun. A small bite is being taken out of the sun by our satellite called the moon. This is incredible. Earlier they were telling people to talk about in one word to describe the eclipse. The word for me is majestic. A lot of times, I don't know about you, sometimes if I want to, take a break on my computer, I can take these out. I will go to the solar, I think it's the Dynamic Observatory that often will give videos of the rotating sun. And Colleen, I don't know about you, but when I see that giant ball of gas just rotating, majestic is a word that comes to my mind. Could you agree?
I absolutely agree. It's amazing, and I think that we're really fortunate to have this opportunity and to be in community with our students and faculty and staff from multiple institutions here at SIU, who's been wonderful and very welcoming. It's just extraordinary.
It sure is. Thank you very much for your time. Keep up the great work. Thank you for talking with us. That was Colleen Fava with the LSU Space Consortium. We have had first contact. I can't believe it. We've been planning for this so long. To be honest with you, I didn't think it was really going to happen just that. I am so focused on talking to all of the experts live at Saluki Stadium. And I don't know if you could hear this because this microphone is fairly directional, but when the first contact, I could hear a collective, from the tens of thousands of people here in the stadium. We have just begun. The fun has just begun. The weather is perfect. And back to you.
Well, I tell you, that's amazing, Chris. Just check out that hydrogen alpha there. You're seeing first contact very clearly.
It sure is. And what we're seeing is we're seeing 3 stunning views of first contact. And hydrogen alpha, calcium K, which is what we see here, and, of course, white light. And I tell you what, Troy, I mean, it never gets old, does it?
It doesn't get old. Every time I see that, when you see the first bite out of the sun, you just feel your heart start to pound. It's funny how it has that reaction to you.
Well, as we're watching first contact, or of course we're past first contact now, we can see the stunning views. We need to get an update on social media. Because I think we had a poll question not too long ago.
Yeah,
we did. It basically was Eclipse in 6, and describe what the eclipse means to you in 6 words. And we've been getting a ton of responses, so keep them coming because we'll keep looking at them.
Did you send one in?
Well, I did on stage. I did. I did. I didn't text one in. I'll get it official later. I think I get a write-in.
You'll get those solar glasses.
I get a write-in candidate.
All right.
There you go.
All right.
What we have?
Well, one of them is in 6 words, don't look directly at the sun. So that
nice.
would be
Yes.
very good.
Very good.
That was a good
Absolutely.
6. Here's another one. So much eclipse, so little time.
That's good. I like that.
Ben, that's a good question because isn't it true in some total solar eclipses, totality will last longer than 2 minutes? Sometimes it can be up to 7-8 minutes or so,
That's
right?
right. Yeah, it just depends on all the angles and direction it's coming from and how long it's going to pass
and
over.
how you define little.
I know, right? Little would be just near, like in my sister's house in St. James.
Right.
It's about 20 seconds. They're right on the edge.
That's like a glimpse.
Yeah, hey, Regina. Had to do it.
What do we have?
I love this one. Playing partial hooky for total eclipse. So
Oh,
this must be
little true confessions.
little true confessions from school.
Okay, so I gotta make an announcement. So my son, his first day of school is today. He goes to school in Virginia Beach at St. Gregory's in Virginia Beach, and so the question is, do you play hooky on the first day of school with the eclipse?
Yes.
And I gotta say, if you're gonna play hooky, and I'm not endorsing hooky in any way, but if you are, first day's perfect. I mean, because nobody, accomplishes much. You can't get too far behind first day.
Right.
And if there's eclipse, I'm going to weigh in and say that's probably a good move.
But one of the things that they are doing, since for the eclipse, they're having an early dismissal, a modified dismissal, because they're using it as a teachable moment for the kids. So they're all going to be outside looking at the sun, looking at the partials, because in Virginia Beach, you're not going to get totality.
Yeah, this is a shared experience with people all across the path and across the entire North America.
That hooky is no joke, because even Keith at NASA Goddard is playing hooky. I don't want to get him in trouble, and I hope his bosses aren't watching. Hopefully they're out watching the eclipse too. But Keith, hang in there. Hope that mannequin you left at your desk at the office fools everyone.
I hope he has an eclipse in 6 because we have more. What do we
have? More. Best experience with science and nature.
Very good. Very good.
Country unites for the solar eclipse.
Yeah.
Country,
that sounds like a poster.
there we go.
And witnessing once in a lifetime event. That's from
witnessing
Anita.
a once, yes.
Yeah. So that's good. And then let's see. Will you hire Lincoln Kenley? Oh wait, that's one of our interns over there. That's one of. Hey Lincoln.
Kind of slipped that one in there just as a question.
Nice resume
builder. 1, 2, 3, 4, 5. Hey, no, it's only 5.
Okay.
So. You know what? More schooling.
Better luck next time.
More schooling.
That's right.
Well, we're seeing, again, we're seeing live images of the sun. This is a hydrogen alpha brought to you by Lunt Solar Systems with the Sun Lab, which is adjacent to the stadium. We see the active region going on, Troy. And of course, as we approach totality, that moon's going to be coming across the disk of the sun. I mean, it's going to get bigger and bigger as we get close to 120.
Will some of these views, will people be able to see through these views any solar flares or prominences? Do you know?
So if for some chance, if we get a coronal mass ejection, or if we get a solar flare and the H alpha, we'll be able to pick that up.
Yeah, Micronesia last year, we actually did see on the upper left-hand limb of the sun, we had a beautiful prominence. It was a flare that was coming out of the upper left-hand part.
And in the days preceding this, during the testing, we've seen a little prominence activity going on. So, you don't know what you're going to see, and that's the beauty, because these aren't images from a week ago. These aren't images from a month ago. These are live images from the sun. So that's really what we see is what's happening, give or take like 8 minutes. I don't know how that works in terms of the time.
Are there any trends you're seeing right now with social media?
Right now, people are, I think we have a total solar eclipse is one of the hashtags people are starting to use as trending.
Okay.
We're still using Eclipse 2017. And right now we're trying to make Eclipse in 6 trend like crazy. So, that's going to be a really nice thing.
Well, we actually have another Twitter question.
We do.
Poll question. Tell us about that.
Yeah, this will be our next question that we'd like for everybody to just basically you can respond to this with NASA Edge Q, and we'll look for those answers to this one. If you could choose just one song to listen to during an eclipse, what would that song be? So if you
Wow.
have just one song.
Interesting.
And even in particular during totality.
During totality.
So you have 2 minutes. You have 2 minutes and 39 seconds. 2 minutes and 40
well,
seconds.
but
So
see,
what
that's-
song would you sing?
Okay, that's a one-track question.
It
Whereas
is a one-track. Yes.
If you're building a playlist, if you're going from first contact to fourth
That's
contact,
right, yeah.
So you got to distinguish what you're doing.
We didn't say could you build a playlist, but that would have been a good one.
Yeah,
What would your playlist
I'm sure
be?
we could build a playlist from everybody's one song because I'm thinking old school "Sunny Side of Life."
I love that.
It's a great song. It's how I feel right now.
But you know,
Oh,
some
it's
of
hot
the-
as blazes out though.
Well, we're gonna give our age, but some of the songs from the 70s are like 5-6 minutes long. You know, so
I know.
I don't know if that would work. You know?
Just pick one part that you like the best out of your Sun's song.
There you go.
Like
There you go.
Sunny Days on Sesame Street or something.
Or
That works,
Sun
too.
King by the Beatles. The Beatles have like 6 songs.
Here
that,
comes the sun. That's a good
yep,
one.
I'll
That's a good
follow
one.
the sun.
But we can't forget about poll question number 1 because we still want to hear about the Eclipse
We
in
do.
6.
Absolutely.
Eclipse in 6,
So
keep
we
it
got
coming.
2 poll questions going. We're gonna see how they're trending, see what kind of songs we get, but also we want
That's right.
we want your feedback in Eclipse in 6 as well.
Absolutely.
And go ahead and put on a music track while you're watching the stunning imagery of the sun because it's going to help, right? It's going to.
You know there's debate about that. I actually had some people tell me that it is such an amazing moment that they want to be in just quietness and listen to just the sounds of nature around them
Okay.
and the animals and all of that kind of thing.
That's a fair point, but
Yeah.
for some of our viewers who aren't in the region and can't see it, this is their best shot.
right.
This picture is perfect for them. So build that playlist, listen to some music, enjoy some totality.
Maybe we'll
and-
hear some of the Saluki dogs. You know, maybe they'll start
Yeah,
barking.
That's
and
right.
Listen for that.
Yeah.
Now, when you were in Micronesia, because that wasn't your first total solar, because you were
No,
in Turkey before,
I was
right?
in Turkey
yeah.
before that. Yeah.
So when you were in Micronesia, you talked about the animals. When it got dark, I mean, did you hear the birds? Did you hear
You know, I
the
listened really
wildlife?
closely to that, and there were only some birds on this island out in the middle of the Pacific.
Okay.
And there were some wild boar, some pigs, and things on the island. So I didn't hear any squealing or birds tweeting or any of that.
Okay.
But everybody on the island, you could hear everybody in the entire island just screaming and yelling and all excited because this time around, they on that island knew what was happening. The last time it happened, several of the people came up and told me, the indigenous to the island, they had no idea that it was coming at that point.
Okay.
And some of them did, some of them didn't, and it scared them because you don't, like right now, we know that partiality is happening,
Right.
but you can't see any difference in the lighting
No.
visually. And that doesn't happen until, in my experience, about 80% coverage, you start to see it visibly going darker, and then within moments it starts going into total darkness. So it really does happen fast from that point of view.
Right.
So people thought the world was ending. You know, what is happening? The sun's disappearing, it's going away.
Right.
And it's really terrifying if you don't know.
Yeah.
So one of the things that we want to get from you later in the show, hopefully, is that since you've seen the one in Turkey and the one in Micronesia,
Yes.
kind of compare and contrast that with the one we're going to have in
Sure.
Carbondale today. That
Sure.
would be kind of interesting.
That'll be great. I'll give you a precursor, is just a little preview. Is the one in Turkey was phenomenal, and I believe we were towards solar minimum, like we are
interesting.
now.
Okay.
And the corona was exceptionally beautiful and distinct. And then last year, Micronesia, it was still amazing because you get this amazing halo, but it didn't have some of the major helmet stream parts and features that I saw before. We're expecting to see quite a spectacular corona today.
Now, speaking of totality, how long was totality in Turkey and Micronesia compared to
It was
today?
around 4 minutes.
Okay.
It was quite a while, and I'm not sure if that's what caused it to get so dark. I was wondering about that because I remembered in Turkey it became like twilight towards the evening, like somewhere around 7:30, 8 o'clock.
Right.
And you could still see people pretty much. But when we were in Micronesia last year, it got so dark
Right.
that from here to you or to Blair, it would be hard to see the features of your face.
Wow. So I guess what you could say is we're seeing the dark side of the moon, huh?
Yeah, absolutely.
Song, see?
That's a good one.
Nice, nice tie-in, buddy.
Yeah,
That's
yeah,
good.
yeah,
No,
yeah.
That's great. Well, and it's interesting because it's growing right before our eyes. I mean, you're seeing more and more of it, and it's
Right.
It's
It just seems like once first contact, it's just bam. All of a sudden, you start seeing the moon. I mean, it's not like it's just slowly coming across it. It's picking up.
It's starting to
pretty
look
good
like a
speed, yeah.
giant Pac-Man race.
I agree with that. I think I thought it would be slower. The last astronomical event we witnessed on the show was the transit of Venus, and it had 4 contact points as well.
That's right.
But when Venus was in front of the sun, it was for a lot longer,
Yes,
and you
it
didn't
was.
sense the movement as rapidly as you
Yeah.
do here, which is
This is
pretty
happening
amazing.
really fast. That was about, 8 hours we were there
Yeah.
broadcasting
8
for
hours.
that show.
Sure.
And if you look at the active regions on the sun, I mean, you see those huge sunspots, which are much bigger than the Earth. and then you see this moon coming across. It's just going to engulf those.
It just does. I'm still just amazed that it's perfectly aligned the way it is, so that we are just the right distance away with the shape and size of our moon to be able to see the sun. Now, to see the eclipse. Now, what's really amazing for people to watch, and this truly is spectacular in the path, is when totality is just about ready to happen, and you'll start seeing something called Bailey's beads. You'll see a diamond ring, and that is caused because the moon isn't perfectly round. It has craters,
That's right.
and the sun's peeking through those craters. You actually do see that. And after all of that disappears, after just a few seconds, I was waiting just to see what would happen if I'd see the corona.
Right.
And I'm like, where is it? And it just whisked right across the sky at that point. And then I started noticing the stars starting to twinkle on planets.
And we'll see some planets today.
Oh
too.
yeah, we should see. We have a chance to see, I believe, about 4 planets and maybe Regulus. It'll be close to the eclipse.
Yeah, that's what Sten said that earlier. Regulus.
Yeah, we have a star chart. If on the eclipse2017.nasa.gov website under resources and downloadables, if you go there, you just look for it, you'll see the star chart, and you actually will see the ones that we're expecting to see today.
I'll tell you what, we're studying the sun today. We have scientists all across the country in totality with their telescopes. But we have 2 cool satellites that are coming up, Parker Solar Probe and Solar Probe Plus. And we had a chance to sit down with Dr. Eric Christian from NASA Goddard Space Flight Center to learn more.
So Eric, today during the total solar eclipse, we're talking about everything solar. And right now we're actually going to talk about some future missions that are going toward the sun. First is the Parker Solar Probe. Tell me a little bit about that.
So I'm working on this Parker Solar Probe. It's launching next year, and it is going to travel far closer to the sun than anything else we've ever built. It's going to get within 4 million miles of the surface of the sun, 25 times closer than the Earth is. And so the sun will be 625 times brighter than it is at Earth. Really, really hot. But that's where all the action is happening. And there's some real questions about the sun that we've got ideas about, but we don't know the answers to. That's what Solar Probe is going to help us determine. Why the solar corona is hotter than the surface of the sun, and why the solar wind gets accelerated up to 1 million miles an hour. Those are really key questions that you would think we have figured out, but it's hard to figure it out from Earth.
Now, I just think about the sun is extremely hot. How can any spacecraft get that close and not disintegrate?
So the Solar Probe mission was suggested more than 50 years ago, but the technology didn't exist. Now we have carbon fiber composite that can act as a big heat shield, and we hide in the shadows. We have this enormous heat shield that blocks the light from the sun and the heat from the sun, and almost all the instruments are hiding behind that heat shield so that we're dark and just room temperature, the same temperature you and I are right now.
I know it's kind of hard to imagine that just a heat shield on the front side facing the sun would protect the spacecraft when all of the heat and everything can come around the outside. Can you explain a little bit about that?
So space is a vacuum, and so not much of it leaks around the side. Same way a thermos works by having a vacuum in between your soup or coffee and the outside. Vacuum is a pretty good insulator. So not much leaks around, but anything that directly comes at you would heat you up if you weren't hiding behind a heat shield that looks like this. This is a small piece of a test heat shield that was done for the Parker Solar Probe, and they tested it and then they cut it up, and I have a piece right here. And so the front part of this will get hot enough so that aluminum would melt. But this won't melt because this is a special carbon fiber material that can take the high temperature. Then with the insulation, the back side of it will be at room temperature, and that's where all the instruments will sit.
Is this the actual?
This is the actual thickness.
Wow.
This is the test. This is a test piece from the real thing.
So on the back side will be all the instruments that are going to be taking measurements, spacecraft, and everything
else. Yep. And
so that's about how much? About
4 inches.
4 inches.
Yep. Mm-hmm.
So what type of instruments are going to be on Solar Probe that will give you the readings that you're looking for?
So the instruments are very similar to things that we've flown near Earth, but these are specially designed to get really close to the sun. It's going to be measuring the solar wind, the energetic particles which are coming from solar flares and stuff. They're going to be measuring the electric and magnetic fields from the sun. And there's actually going to be a camera that looks off to the side that sees the corona that we're seeing in the eclipse. It'll be looking off to the side and measuring the corona that actually moves past the spacecraft for the first time. So from inside the corona, we're going to be looking at the corona with a camera. But it's going to be a remarkable mission.
Now, how often will we be able to communicate with the solar probe during this mission?
So it's going to take multiple orbits in close. It'll basically orbit between Venus and the sun, get really close to the sun, and then come back out all the way out to Venus. It does that about every third of a year. Every third orbit, it'll actually get really close to Venus and then maneuver so that it gets even closer to the sun. So the first time we go in, within half a year, we'll be closer than any other mission has ever been to the sun. But to get to the closest approach, where we're only 4 million miles away, will actually take 6 years of Venus helping us get closer and closer and closer.
How long will this mission last?
6 years.
6 years total?
Yep. If it's still working, we'll keep it going longer, but eventually we'll run out of fuel. And since we have to keep the heat shield between the instruments and the sun, it means we have to be, as we go around, we've got to be constantly changing the orientation of the spacecraft. When we run out of fuel to do that, it's not going to work.
Okay, let's look at our second mission. It's the Solar Orbiter. Tell me a little bit about that.
So Solar Orbiter is going to launch a year after Solar Probe does, but it's going to overlap, and they're both studying the sun. Solar Orbiter is a European Space Agency mission with some NASA involvement, and it's going to only go in basically as far as Mercury. So it's not going to get as close to the sun as Solar Probe does, but what it's going to do is, using Venus again, it's going to move itself out of the ecliptic plane, this flat plane that all the planets lie in, and it's going to tilt itself out of that plane so that it can look down on the North Pole and up on the South Pole with cameras. And we've never seen the North Pole and the South Pole of the sun. In all the years we've been studying it, we've never had a camera that's not been in the ecliptic plane.
So what do you think you'll see?
There are important things that happen at the poles as far as the magnetic field and the turbulence and stuff goes that we've not seen. We've sort of estimated, but a camera that's looking from Earth, just sees a haze at the edges, and stuff. And so we're hoping to understand how the magnetic field moves, including the poles, which lets you tie in the entire sun and figure out what's going on. The sun is a magnetic star, and it's the magnetic field that causes solar flares, coronal mass ejections, all the space weather that we get. And without understanding the entire magnetic field, you're missing some of the pieces of the puzzle.
Hey everybody, we're back here in the science demonstration area, and I'm joined by Ms. Carolyn Ng, who is the public outreach person for the Parker Solar Probe from the Goddard Space Flight Center. How you doing, Carolyn?
Great. Thank you, Franklin.
Yes. Now, Carolyn's going to talk to us a little bit about the Parker Solar Probe, and then we're going to do a demonstration here with Carolyn, Ashley, and Abby? Jessica, I'm sorry. I'm trying to, so many names I'm trying to learn today. They are Girl Scouts who have joined us here at SIU from all across the country, and we're going to get into that demonstration in just a few minutes. But Carolyn, tell us a little bit about the Parker Solar Probe.
Yeah, in 1 year or so, NASA will be launching a brand new satellite called the Parker Solar Probe that will fly from Earth towards the sun, and it will get very close up to the sun to study its upper atmosphere.
Now, this is the first of this type of project, right?
Never has NASA sent a probe so close to the sun with the help of Johns Hopkins University, the Applied Physics Lab there.
Okay, so today we're going to do a demonstration with the Parker Solar Probe. Exactly what is this demonstration going to show?
Whenever you ask people how big and how far is the sun, people have a hard time. Even if they can tell you the numbers, it may not make much sense. So we have a tool, a visual tool, that will demonstrate the distance between the Earth and the sun. And then we'll add the probe later.
Okay.
Would that work?
That works just fine. Okay, so now we're going to give the disc of the sun to one of our Girl Scouts, and she is going to do what?
Ashley has a picture of the sun. It's a real image of the sun taken by one of our satellites, and it's about 8.5 inches across. So she's the big sun. And Jessica has little Earth. It's so little. Can Jessica hold it up? You have to have white space around it. Okay. So it will be showing on camera. Mm-hmm. So now they have to step apart. Guess how far they have to be apart to demonstrate to scale?
Well, we'll find out, I'm sure. So the sun is about to go that way, right?
Yeah.
Okay.
The sun will be away from Earth. So let's move a little bit out there that way. Right? Yeah.
Okay.
Bye-bye, sun.
Bye-bye, sun. I think our camera's going to pick up the sun as it moves toward its location in our solar system. All right. She's almost at her mark, and she is there. Okay, what's next?
That is actually 75 feet away. Can you believe that? And we need Jessica to hold up little Earth.
Okay, Jessica, walk over here toward the fence over here. Okay.
Right there. So that's the distance to scale between sun and Earth.
Then there's the Parker Solar Probe. Tell us about it.
So it is being built at Johns Hopkins University right now, and we will have Abby mimicking the probe, and she'll be flying towards the sun. So are you ready?
All right, we're about to go ahead, and the probe is about to move toward the sun. Go ahead.
Abby, you are the probe. She's flying and flying. Actually, it's not a straight line. It will actually take the probe 7 years, 7 slings around Venus to get close to the sun.
Okay, now Abby is in her position, and she is how far away from the sun?
Abby is at 3 feet away from the sun. Can you imagine how close up that is?
That is pretty close compared to where she started here back at Earth.
So that's the position, the very closest approach that the Parker Solar Probe will get to the sun.
All right, that is so awesome. Right now, that is just some awesome information. We want to thank the Girl Scouts that joined us today to show us the sun, the Parker Solar Probe, and the Earth here in the science demonstration area. Carolyn, thank you very much for being with us today.
My pleasure, Franklin.
And right now, we're going to take it back up to the main stage with Mr. Chris Gersh.
Hey, thanks, Franklin. We're joined again by Robert and Lou. Boy, what a great activity for the kids to do on the Parker Solar Probe. It's amazing how close that satellite is going to be to the sun.
Yeah, it's incredible, really. And Lou and I were just talking about, to get that close, it's, 4 million miles, really, with the 93 million miles that we are away from the sun. It's a hair's breadth, really.
And speaking of Lou, we have some questions on Parker Solar Probe. Let's go see how much you know. All right, stump the scientists. Here we go.
At least it's not dark matter. That would be a tough one.
Yeah.
And we heard about this a little bit in Eric Christian's prepackaged piece. But how will Parker Solar Probe survive being so close to the sun?
Oh, well, it has a shield in front of it. The instruments are on the back side of that shield, and that shield is going to stay between the instruments and the sun. And that shield is very effective at reflecting and disseminating heat.
Very good, very good. Yeah. What will happen to Parker Solar Probe when it completes its mission?
Well, I think just like lots of other missions, the missions are very well designed, and it can continue to potentially operate. But eventually, where it is, we will not recover it or retrieve it. It will journey out into, around into space, really. But these sort of missions are designed to not just complete the minimum what's going on, but to last for a long time. The prime example of that being Voyager, for example.
Now, I understand, Lou, that when Parker Solar Probe is orbiting around the Earth, the heat shield has to stay in between the sun and the instruments behind it.
Yes.
And of course, once the fuel runs out, the instrument can kind of, the spacecraft can kind of wobble, and then it's pretty much lights out for this.
Right. You've got to maintain. I think it's hydrazine probably that they're using to maintain the pointing.
Right.
And I don't know if they're using gyroscopes, but all of that has to work.
Right.
And when it doesn't work, then the mission is over.
But before that happens, we're going to have collected a ton of data on the sun.
Amazing, flying through the corona of a star.
Right.
You know, that in itself is just an amazing thing to do, to gather the material there directly and to try and sample the region which, you know, we've virtually thought was impossible before.
We have one.
You were talking about how the Parker Solar Probe is going to probably overextend its predicted lifetime, and how Voyager did that.
Yeah.
So many NASA spacecraft now are exceeding their lifetimes. The MER rovers on Mars.
Spirit and Opportunity.
Spirit and Opportunity. Cassini had 3 mission extensions. We're going to say goodbye to it on September 15th, but it significantly outlived its purpose. So,
and Curiosity has gone longer than expected, right?
It's beyond its lifetime. Its lifetime is a little more bracketed because it's using nuclear power source. But yeah.
Got another question for you. This is an interesting question. I haven't heard this one before. How is Parker Solar Probe related to the Eclipse?
Well, it's not really related to the Eclipse as we think about it, except for the fact that it's studying the sun and the solar wind, fields and particles that come out from the sun, and to that extent the sun is part of the Eclipse. What'd you say, Robert?
Yeah, I would agree. Like, one of the things we're going to do with the Eclipse is trying to understand the corona better, and particularly the heating of the corona. And the Parker Solar Probe is going to probably confirm some of those observations, some of those theories, and probably give us new ones and new challenges as well for future eclipses to look at. So there is a connection in regard of the science area, but of course Parker's Solar Probe is not launched yet, and therefore is not directly involved in observing this solar eclipse.
Now, I see you got some glasses on. You've been looking at the sun. But we have some great, stunning telescope views of the sun in 3 different wavelengths. So you got calcium K, which we're seeing here.
It's so much more than when I saw you minutes ago.
That's right.
That's amazing. Look at that.
Oh my goodness! Right on.
That's white light. Okay.
Right on schedule.
Yeah, our screen looks like it's a little colored, but yet it's white light, and it looks like it's about to engulf all those the active region that we see right there in front of
it. Yeah, it looks like it's going to cover that. Remember, those sort of active regions are around about the size of the Earth, so it gives you an idea of the size of this arc that's cutting across the sun at this moment in time. This bite that's being taken out of our blazing star, really, and it's like that. Just to see that, to see the edge of that is just incredible. Actually,
and here we're seeing calcium K now.
Oh wow!
Right, so we're seeing up into the chromosphere right now. As you see at different wavelengths, you're seeing at different temperatures and different depths into the sun. You see different features. The other thing you can see is limb darkening. You can see the edges of the sun are a bit darker than the center. And this is just a byproduct of the fact that the temperature is dropping as you move outward on up to the surface of the sun. Well, here we have another image.
This is hydrogen alpha. Hydrogen alpha again, showing you again the chromosphere and the activity and the various things you see there right up to the limb. The sun is a beautiful object. It's very intricate, it's dynamic, and it's challenging to understand. But when you see something like this, you certainly are moved. The sun is not it's a ball cue ball. It's a very involved, very dynamic and structured celestial object.
We got a couple more questions here, but before we get to that, you know, we got the scientists on stage. We've had a couple of poll questions for our general public. They're giving us some great responses. And so poll question number 2 is, if you could play any song during the eclipse, in my case I would say in totality, what song would you like to listen to during the eclipse?
Just to put me on the spot, there's a song by They Might Be Giants about the sun. And they sing about all the different aspects of the sun, the elements that are in the sun. And I use that a lot with the outreach that I actually do with particularly primary school or young children. And they really, really enjoy that. So the sun is a mass of incandescent gas by the They Might Be Giants.
What do you think, Lou?
Oh, there's no question about it for me. Paul McCartney, Venus and Mars. Sitting in the sports arena waiting for the show to begin.
That's awesome.
One of my favorites.
Got some more questions. Here's a good question from Jared on Twitter. Do planets ever cross the path between the Earth and the Sun? Luke?
Well, they certainly do. They certainly do. In fact, Chris, you were there with us when we were on Mauna Kea looking at the Venus transit, where Venus went between the the Earth and the Sun, right? That's pretty rare, but we got to see it. It so happens that on Mars, I think it's in 2084, the Earth is going to transit the Sun as seen from Mars. So maybe we'll get to see it. Maybe we'll have people on Mars by then.
That would be very cool. And I think, don't we have a Mercury transit coming up here in a couple of years?
2019, I think, right?
Yeah.
2019.
But of course, Mercury a lot smaller than Venus and more difficult to see. But yeah, again, another example of an eclipse.
So here's a good question. You talked about in 2084, you're going to have if you're on Mars, you're going to have the Earth. Would the disk of Earth appear bigger or smaller than Venus when we saw the transit in 2012?
Well, Venus and Earth are roughly the same size. Venus is about 95% the diameter of the Earth. Let's see, and Venus, I think, gets a little closer, just a little bit closer to Earth than Mars is going to get to the Earth. However, Mars' orbit is a bit eccentric.
Okay.
And so it kind of depends on where Mars is in its orbit, how far it will be. But I would say the Earth will appear a little bit smaller against the disk of the Sun than Venus did.
Very true.
I was trying to stump the scientists on that question. That's like, you got to come up with a difficult question.
You have to think fast.
Yeah. You try harder. But,
Okay, got another question. What are the rays coming off the edge of the Sun? Are those solar flares? Let's see if we can bring up the hydrogen alpha image. That's a good question.
Yeah, it is a good question. What that is material arching out from the surface of the Sun. If you look at hydrogen alpha and you see these sort of like flames or rays coming out, that is material that's hanging in the atmosphere. We call those prominences when we see them at the edge, and they hang there suspended by the magnetic field of the Sun. It's like in magnetic hammocks.
Wow.
Really. And then sometimes, they actually twist up and erupt outwards, and they will be the source of these solar storms or coronal mass ejections.
And this is cool. This is the moon here. On the right, that we see the disk of the moon. And of course, on the top left-hand corner, you see the left edge of the top left edge of the Sun. So this is actually the moon that we're seeing close up. And I believe if that's a sunspot on the screen, it's getting ready to engulf that whole active region.
It's amazing. Again, those are regions of strong magnetic field. That's why the dark when we see them in the white light and bright when we see them in the hydrogen alpha. Those are areas where we really, are looking at strong magnetic activity that can be twisted up, and when it gets twisted up magnetically angry, that's when your solar flares.
Now totality, because again, it's just a short bandwidth across the country. It's about 70 miles wide.
Right. About that, yeah.
So another question I have from Jen in Indianapolis: why do some places along the line of totality have more coverage than others?
More coverage.
Coverage.
If you mean the duration, then it depends on where you are. On the first of all, center line to the edge, you're going to see less coverage. You step over the edge, and it's not total any longer. And then the geometry, the Sun, Earth, Moon geometry changes a little bit as the Moon moves along its orbit, as the Earth spins, and the eclipse progresses. So all of that conspires to make a little bit less duration in some places, and maximum duration here in Carbondale.
Yeah. So max duration here is just south of us, right? It's about 2 minutes and 40 some seconds.
Yeah, I think we're about 238 here.
238 here.
Yeah, but something like 6 miles south.
And we were talking about this earlier. Sometimes you have a total solar eclipse. The duration could be more than 2 minutes, 3, 4, 5, 6 minutes long.
Up to 7. That is a theoretical maximum. That's right.
I tell you what, we got some great views, and what we're going to do now is we're going to go to Franklin in the science demo area. He's with Brian Stevens to learn more about the cool telescopes that we're seeing. Take it away, Franklin.
Thank you, Chris. Yes, I'm back here with Brian Stevens in front of the Sun Lab. Brian has been inside with his team all week, and they have been providing some of the most magnificent images I've ever seen before. But one thing that you actually told me earlier this week is that people can actually buy these same telescopes and get these same views.
Oh yes, absolutely. That's actually what we do, is we actually build these telescopes that are on the optical table there for the general public. So pretty much anybody who wants to can get into this hobby and enjoy looking at the sun every day. A lot of people look at the stars every night, and some people find it difficult to get out there in the dark sites and stuff like that. So we have a lot of people that actually enjoy coming to watch the sun on a daily basis. There's always something new to see.
Now, one thing that happened when we just started our interview is that we moved into the shade. And what does that do for viewing of the sun as far as not seeing the sun?
Well, moving into the shade, you're not going to see the sun. We've had some clouds actually come across our actual field of view, which is actually inhibiting what we are actually seeing. I think people have seen any of the feed that's been going on can actually see the clouds travel across. Standing in the shade, you can actually start to see the shadowing in the between the leaves if there's gapping, but people do what they want to do.
Absolutely. We have a couple questions that came in from Twitter. Alex asks, can we take pictures of the sky from phones during the eclipse of the sky?
You can. Well, it's going to be awful hard without any type of filtration to take a picture of the sky. You could put them up. You could put your cell phone up behind your glasses and try to get a shot of that. Just keep in mind that when you actually do that, you yourself, by holding the phone up, are typically putting your eyes at risk by looking directly at it. If you miss by your screen, so just keep safe and give it a try. It's not. Other than that, there's really no reason why you couldn't.
We want to do some safe viewing today during the eclipse. A second question we have from Cindy is, can we see solar flares during the eclipse?
Yeah, we certainly can. More than likely, everything that you saw around the outside edge there in the hydrogen alpha should be totally visible by the naked eye during the eclipse itself, during only totality. People have to remember that. They can look at this, they can look at the corona and everything around that during totality, but at the minute it starts back up, it's time to get their safety glasses back on and stay safe.
Now, we have views of you can see the sun in its entirety on the calcium K, but just a part of the sun on the hydrogen alpha. What's the difference between seeing those different sizes of the sun? Is it because of the different size telescopes?
There are different size telescopes. We've designed them so that they actually kind of give about the same size image. The reason people are seeing that the hydrogen alpha version is actually closer, so that we were asked to do so. So we actually put a couple more lenses in there to actually bring us a little bit closer to the surface. For the most part, we could do the same thing with calcium K, but typically you can see most everything with that. You can see calcium K flares, but it tends to you have to overexpose the image quite a bit to actually pull that, and so that people lose the detail on the surface. So we will actually just kind of middle of the road kind of setup.
Now, when we're looking through our glasses that we have for the eclipse today, we can actually see sunspots on the surface of the sun, and they're black. But looking through like the hydrogen alpha telescope, they come through showing white. Why is that?
We've actually, Stephen Pizzo's actually done a curve on the actual image itself. So basically it inverts the center area while keeping the outer area in a positive. So what you're actually seeing is a positive prominence area out on the edge, and you're seeing the internal actually being negative, which actually gives us the detail to actually show on a video scale.
And when we see the video of the hydrogen alpha, it actually, I use the word, looks like the sun is breathing. It looks like it has hair. Yeah. Tell me about that type of detail.
Well, some of that actually is the atmospheric conditions actually giving us a little bit of that, some vibrations through the system and stuff like that. But it does. There's a lot of movement on the surface that's happening, and even in short periods of time, you can actually see that movement. So it will give you that feel of breathing.
Breathing. That's my word, ladies and gentlemen. As I look up into the sky right now, I can actually look up because the sun is behind the clouds, but it is on its way out, and right now I see those hard shadows, so it tells me that the sun is breaking through. Everybody continue safe viewing through the rest of the eclipse, and right now I'm going to send it back up to the main stage with Blair Allen. Blair?
Welcome back. You just got a brief look at the sun. We're about 45 minutes away from totality. And with me now is Jim Razor from WSIL TV3 and Reynolds Wolf from the Weather Channel. And we're going to have to talk about this weather issue because it's on everybody's mind as they look up and they see the clouds coming in. First, let's talk with you, Jim. Jim, tell us a little bit about the local outlook for weather here in Carbondale.
Yeah, I think we saw in the imagery that was just running the clouds coming through and covering things up. And we've got quite a bit of a cumulus field out here right now. We expect that to stick around into the shadow. I think once the shadow starts to build, those should start to dissipate like we see locally every day right around sunset. And you can see some of those clouds showing up. They're sort of building right now. Off to our east, actually, looks like storms are building closer to the Ohio River. But that's all moving away from us. What's coming at us is just a few of these cumulus clouds, and I don't think they're going to be a big issue. They're a little bit of an issue right now, but they're also very progressive, so that they may block our view for 30, maybe 40 seconds, and then move right on out.
You know, I'll be honest, I'll take 30 to 40 seconds, as we get through this. It's such a great experience. I don't mind a little cloud cover.
We've got a couple of minutes to play with.
Yeah, and so Reynolds, looking further, looking beyond Carbondale as the eclipse moves forward, what's the weather outlook for those other locations that are waiting to view the eclipse?
Yeah, the farther you look downstream, for example, if you go to Nashville, Tennessee, Nashville, I believe last we had was about cloud coverage, I think 13%. Not too bad, only the banks of the Cumberland River. But if you make your way to places like Crossville along the I-40 expanse, it's going to be fine. North Georgia looks okay. Clemson, South Carolina, starts to get a few more clouds in the fray, and then we find ourselves in the lowlands of South Carolina, and it does appear, I'm thinking in Charleston, I'm banking on the sea breeze and I'm banking on the clouds. I don't think it's going to happen. Very unfortunate.
I tell you, and it's a tricky thing, right? I mean,
Indeed.
you have all this data, but you just never know. You kind of have to watch it unfold to be sure, right?
Well, it's one of those situations where in the case of Charleston, there is no time in the world I'd rather be wrong with the forecast. I'd love to blow the forecast and have pristine blue skies, but I just don't see that's in the picture for it. But at the end of the day, and I'm sure Jim would agree with this, the hay's the barn. You have to accept whatever nature gives you.
Well, that's true, and that's the other thing that we have to think about too. Is I was thinking of weather right up to the eclipse. I was very egocentric, I was like, once we get to right after totality, I'm fine. But really, we have to think about weather and events like this all across the country where people are gathering and enjoying watching the eclipse. We have to think about the weather beyond that. Jim, tell us a little bit about what we can expect here for the rest of the day.
One of the things we're watching here is we think storms are going to develop later on in the afternoon, probably right around the end of the eclipse. So we think we'll still have crowds gathered, and if we've got lightning around, it becomes a safety issue. And just want to make sure everyone's aware of any of those chances out there in any of the locations.
Yeah, you can get kind of like tunnel vision, like you just want to see it. And, have either of you guys actually experienced an eclipse? I'm wondering whether your weather-related jobs have taken you in the area of eclipse viewing before.
Nothing of this magnitude, nothing like this. This is the Christmas morning moment, no question about it. The way it looks, there's a giant present waiting under the tree that has all of our names on it. And all you want to do is get to it, unwrap it, and enjoy. The grandeur of this is so incredible.
Yeah.
It's unparalleled. It's unbelievable.
It's interesting as we think about this. It's also so exciting to experience it with so many people. I mean, it's something that, if you're in your backyard watching, it'd be amazing. I'm sure it'd be great. But thousands and thousands of people have congregated to see this, and that has to be quite special.
It really is, and I'm the local guy here right now, and it seems like every group I've stopped and talked with this morning, they're all from somewhere else. Yeah. So they all came here to see it, and it's kind of made it even more special for those of us that are from here.
Yeah, and it's interesting. So for someone like Reynolds, who's not a local here, you had to endure a little bit of a unique situation in terms of lodging, because the Weather Channel really doesn't take responsibility for you once you leave the building, right?
Once we leave the building, we're basically on our own. Well, Jim Cantori and I are actually staying on campus at one of the dorms. Jim has a new nickname. It's not Can Man, it's not Cantori, it's Roomy. So yeah, we're enjoying the college experience again. But I agree with what Jim said. The great thing about this when it comes to the human side of this is you've got people that are coming from all over. And let's be honest, not trying to delve into politics, but the last 18 months to 2 years, it's been a tough time in America regardless of who you vote for. Yeah. But in a situation like this, old, young, rich, poor, doesn't matter where you came from, we can all unify. We're all breathing the same beautiful, clean air. We're both seeing the beautiful sights from high above. it's unifying, and that's so beautiful.
It really is, because you can just see the joy on people's faces. They're walking around, you look around, they're looking up, they're observing things, and that is just a unique experience.
Absolutely.
And glad everybody, you guys are even here. Well, we're coming into your area, obviously.
Welcome.
But it's great to be here, and the people at SIU have been tremendous.
No doubt.
And so, so neither of you have seen an eclipse before?
Only partial.
Only partial, okay. And was that here or was that elsewhere?
One was here in southern Illinois 15 years ago or so. And quite honestly, I was so unaware of it. I didn't know that it was coming. I was outdoors, but I recognized something was changing. I ran inside, I grabbed a pair of binoculars, flipped them around backwards, and took the light on a board and watched the whole thing, sort of a make-do pinhole.
That's awesome. And just weather related in terms of that. And you probably didn't know when that happened, but does the weather actually, two questions, does the weather actually change during an eclipse, or does an eclipse actually impact weather across the path as it travels?
You want part of that?
I'll do a part of it. I mean, in some places I think the effect is going to be gradual at that, but it will be effective. One of the big things that we will notice in terms will be behavior, animal behavior. Out in the tea times, we've got a cruise out there right now in Jackson Hole, and we've heard reports of the elk beginning to bugle. The wolf patterns change for a brief moment. They're nocturnal animals. They do a lot of their hunting at night.
They think it's dinner time.
It's going to be a dinner bell of some sorts, but amazing times. But in terms of affecting the weather, I think maybe a slight cool down, but then it's going to feel like southern Illinois all over again.
Well, we can, or as others have told us today, just like the corona.
Oh yeah, there you go.
Very hot. Now, obviously, if it has no small-term effect, it has no long-term effect either. And I understand that part of that's true because eclipses happen all the time. Well, not all the time, but just not so often over populated areas. Do you guys in your weather work, do you see the effect of eclipses when they happen far away? Does that impact things either regionally or locally?
I don't think we do directly. I think it's highly localized. We anticipate today we should pick up a different breeze out of this because it's changing where the thermals are. We're already seeing the clouds we were talking about a little while ago, they're already getting shorter. They're losing some of that convective energy, and that's sort of what we thought. It's just like the sun's going down in the middle of the day. We're just going through that sunset process.
And just let me, what you said earlier about Charleston. There's no chance that this phenomenon that's erasing the clouds, as this comes across it would do the same thing for our friends in Charleston?
Well, the thing is, I mean, the process starts early in the morning, and when the sea breeze builds up in the afternoon, you've got the battery, you've got the Ashley Cooper rivers, Charleston Harbor itself, everything works together like a beautiful machine. The one thing that may be the caveat is all eyes are going to be towards the west. So if you're on one of those high-top restaurants in the battery, and you've got a clear view, hopefully the skies, if you have a pocket or two, a window or two, you may make it lucky. But I would say that from the coastline going deeper, it's going to be more of a story of a lot of these things building up. It's going to be hodgepodge.
As you said earlier, there's not much we can do to control
Absolutely.
the weather, and it's more about giving the perspective or getting the perspective so that you can prepare. And we just hope that our friends down there can take advantage of what they've seen so far, and maybe it'll break up. But we are providing some great imagery, and not just here, all along the path people are collecting imagery. So even if you don't get a perfect total eclipse experience, at least you know that you'll be able to see it later, and certainly there are lots of stories of real good eclipse stories, and we can be happy about that. Any final comments from you guys, any words of wisdom, any thoughts or anything you'd like to share regarding the eclipse before we go on?
Words of wisdom are tough, but what's going on right now, that's almost half, looks like to me, maybe a little short of half. And if you look at the blue, it's a different shade of blue than it was 45 minutes ago. And it's that change in the amount of light energy coming in. It's the change in the convective energy. We're actually losing a little bit of haze maybe that was trapped. And we're already seeing some pretty big impacts just from the little bit of shade we have right now.
Well, the words of wisdom I would offer would be echoing something that I had on a broadcast earlier with Lou Mayo, brought up such a great point. And the point is just to put down the cameras for a moment, grab the kids, grab your loved ones, and enjoy what we're seeing unfold. It's a humbling experience. It really is. It really puts our perspective as to where our place happens to be in the greater universe. And let me tell you, we are pretty insignificant. There are some great forces out there at work, and nature is certainly a powerful lady, no question.
Very well said, and thank you guys so much for coming on the show. We really appreciate your expertise and your insight, and more importantly, we are very glad to share this experience with you, and let's hope we have a great eclipse as the weather unfolds.
Absolutely. Thanks for
Great.
having you.
Now we're going to take an opportunity to join our friend Franklin, who's actually going to talk to Autumn Burdick, who's going to work with us and tell us how you can participate, not just as a viewer, but as a scientist. So let's go to Franklin now. Franklin, how are things?
Thank you, Blair. Yes, we are back in the science demonstration area, and I'm joined by Miss Autumn Burdick, who is the communication director for the NASA Globe Observer app. And Autumn, tell us a little bit about NASA Globe Observer and what you're going to be doing today.
Sure, thank you, Franklin. So we're hoping that everybody across America will do some observations of the solar eclipse, taking measurements of air temperature and clouds. And this is something that is a citizen science project that the GLOBE program, which has citizen science to its core and has been going on for over 22 years, has made available to everyone. The public can participate in this.
So we have your iPad hooked up to our system today, and you're going to go ahead and run us through the app right now. So tell us what's going on.
Sure thing. So the app is asking you to measure the air temperature, right? And you need a thermometer for that. So hopefully you have one already. If not, find a friend. See if you can borrow one. You can use a liquid thermometer. You can also use a digital thermometer. And for this, I'm going to use the digital one. Would you mind holding that, Franklin?
Gotcha.
Okay, so within the app itself, we're going to see and open up to the total eclipse page. We have a couple different information areas. The red box will walk you through it if you need some instructions. The yellow box is what I'm going to click right now. And there I'm going to select what type of thermometer I'm using. We're using digital, so I have selected that. And it happens to be in Celsius. Selected and X out. We're now going to enter our data. Select the enter data now, drop down, and it is what temperature?
31.7 degrees Celsius.
That's pretty warm, you guys. It's really hot here in Carbondale. So I'm just going to scroll until I see 31. No, now it's gone up. 32.1? Wow. There we go. I'm going to hit save with the green button, and it's saved. So now it's asking us if we want to make a clouds observation. And I'm going to open that up so you can take a look at it. We're not going to run through the entire thing right now, but what we want you to do is also take pictures of the clouds. So I'm going to hit yes for that. And what's really great about this app is you don't need a Wi-Fi connection to use it. You need a Wi-Fi connection to get it. Once you have it, you're good to go.
By the way, where can you get it?
You can get it at the App Store, Google Play, or Apple App Store, and just search Globe Observer. So I'm going to hit next there. It's gotten my longitude and latitude. And it's asking me what types of clouds I see in the sky. So these questions are going to come up. You don't need to know the names of the clouds. The pictures are there. You just need to pick them. So I'm going to say we see some clouds. We do have some clouds here in Carbondale. And then I can select different amounts and then the color of the sky, etc., etc. And this is really good because this is going to inform the general public, people like you and I, and NASA scientists about the atmospheric conditions that occurred during an eclipse. Now, what I want to show you on screen here is the observations that have come in already. Now, take a look at that. Isn't that crazy amazing? All over the nation, and in Mexico and Canada and Alaska. Observations are just flying in, and more data is to come, because as the eclipse continues, and even after totality, we're asking people to make observations because we want to see how cool it gets during an eclipse.
Now, these are observations that have come in over the course of today, or how long has this data been being collected?
Right, so this is live data. We had people practice over the weekend, so we had a couple of these maps go out earlier this weekend, but this is actually right now. So if I take it right to the end of more data to come, that's right now.
That's pretty much, that's about 85% of the United States.
Right, and you can zoom in to your area, which is really cool too. So one of those dots, if you made a measurement, that's you. And you can take a look at this. It's just at observer.globe.gov/eclipse2017/data.
Now, yesterday when we were going through this app, we got to the section where we started taking detailed observations of the clouds. Now, we have a few more minutes left today. Are we able to get back into the app?
Absolutely. Let's go there. I'm going to open up the app. and we're going to hit, well, not that. Let's make some observations.
Okay, let's go
here.
check out a couple observations.
Okay, Franklin, I'm going to have you help me with this.
Okay.
So how much of the sky do you think is covered by clouds?
I'd say about 80%.
Okay, so we're going to click 50 to 90, which is broken. We're going to hit next. Now we're going to take a look at the high level clouds. So those are the ones about up here. What do you see? What types?
Cirrus?
Okay, sounds good to me. Any contrails? Now contrails are created by airplanes. Do you see any of those?
No.
No, I don't see any either. Okay, so now we move on and pick the opacity. So that's how milky the sky is.
Translucent.
Sounds good. Hit next. Do you want to do a mid-level or shall we move on?
How much time do we have there, Ron? Oh, 2 minutes left.
Okay,
you think
we can do this quick. Okay, what do we see? Let's do altocumulus. Sky covered by clouds, broken. Opacity for the mid-level is translucent. Hit next. Now, I know you're worried about clouds. That's a problem. But you see, the clouds are part of the atmosphere, and it's something we like to measure. And just as a note, as a part of this app, you get to compare those observations with satellite observations. And that's a really cool aspect. So check out the satellite little icon at the bottom.
I see that.
Yeah, that's going to be something you can do. Okay, no low level. Yes, we got some low level. I think we got that. Some cumulus. We got some nimbostratus and some cumulonimbus, which is a mouthful. And we're going to do broken again. And down there, it's also translucent. So we have to do surface conditions. Shall we continue?
Yes, let's continue until we get the cut.
Okay. No snow ice, no standing water. Not muddy here, definitely dry. It's hot and dry here. Leaves on trees, yes. Not snowing.
As you continue to run through, everybody can see what you're doing. But what this tells you is that there's a lot of detail that goes into making these observations, and it's the Globe Observer app. So how is all this information, again, going to be used when it's collected?
Yes, that's a good question. So all this data is accessible on the Globe website in the Viz section. So just go to www.globe.gov, and you can use it. Students across the world can use it in their research projects, but NASA scientists will access it and can use it in their research as well.
This is totally awesome. You know what? I can actually download that onto my phone. Yeah. I'm going to go after we finish with this broadcast today, and after I take a couple more looks into the sky. I've only actually looked up into the at the eclipse about 2 or 3 times because we've been working with the broadcast, but I definitely want to get involved and work with the Globe Observer app. And Autumn, thanks for coming on. I think you're coming back later on to give us your observations on the eclipse.
Yeah, that will be great. I'll see you then.
Okay. Autumn will be back shortly in our broadcast, but right now we're sending it up to the main stage and with Chris.
Hey, thanks, Franklin. I tell you what, Lou, it's always great to have people from all around the world participate in citizen science, where they can get data and collect it and take that data and upload it to sites around the world.
Oh, absolutely. We can connect the entire planet now in a split second.
That's right. And the way technology is nowadays, I mean, we're going to be talking about a Citizen Kate experiment later in the show, where there's people right now all along the path of totality that with the telescope collecting data.
That's right. We're hoping to take images all along the path for the hour and a half that totality occurs from West Coast to East Coast.
Right.
And then stitch those images together and get an hour and a half video of the corona. And this has never been done before.
Well, I'm looking at my clock. We're less than 30 minutes away from totality.
Oh, my goodness. I'm about not to be an eclipse newbie.
And don't forget, if you're watching from home, especially if you're in totality, make sure you have your glasses, your sun eclipse shades. If you've got binoculars or telescopes, get them ready, because less than 30 minutes here around Carbondale, we're ready to go.
Oh, you bet. And if you don't have glasses, we just got a call from some people who don't.
That's right.
You can still see the partial phases by making a pinhole camera, get a spaghetti colander, put a hole in a piece of paper, and you'll see an image on the ground of the eclipse.
Right. Oh, you got some more questions from our viewers.
Let's do it.
They're rocking. There's so many questions coming in, Lou. This one's from Alan on Twitter.
Okay.
What are the most significant visible and non-visible changes that happen in the ionosphere and magnetosphere during the eclipse?
Oh, that's a great question. Well, we're actually going to measure some of that. We have groups of people standing by to look at radio emissions all over the world at different frequencies to measure all of that. So we're not entirely sure, but we should see changes because we're going to have the moon kind of blocking the particle emission from the sun, and that will affect not only the ionosphere, because the ionosphere is individual charged particles, right, but it should affect the magnetosphere, and I'm not sure what the changes will be, to be honest. Right. So, but we have a lot of people measuring this, and we'll know after the eclipse.
I got to say, as you giving that answer, you felt this breeze coming on us. It's been really hot here in Carbondale over the past several hours. And if you're looking at the live telescope, this is H alpha.
Look at that.
It's getting closer and closer. So I'm wondering, are we starting to experience a temperature difference less than 30 minutes away?
It's possible. We're going to experience much more significant temperature difference as we get closer to 90% coverage and so on. And we also expect winds to pick up. Right. The temperature may drop as much as 20 degrees Fahrenheit. And it's going to be kind of eerie. Right. Because this isn't supposed to happen in the middle of the day.
We got another question. Well, this is Bill in Carbondale, right around here. Is the ISS doing experiments with the eclipse?
The ISS will be filming the umbral shadow of the moon on the Earth as it flies over from its altitude of something like 120 miles or so. Right. So we're hoping to get those images in, and we'll make them available as soon as we get them. And it's one of about 14 spacecraft that we have that will be viewing the eclipse in one form or another.
And that's a good point. You mentioned these 14 spacecraft. Tell us a little bit about these 14 spacecraft and what are they trying to analyze from this eclipse?
Sure. Well, first of all, you can find out what NASA space assets are involved in the eclipse by going to eclipse2017.nasa.gov. And we have a variety of spacecraft that are going to be looking at the eclipse. We have some that will be looking from the Lagrange 1 point, which is a place where gravity balances between the Earth and the Sun. It's about 1 million miles from the Earth. We have some in Earth orbit that will be looking at the shadow of the moon across the Earth. We have the Lunar Reconnaissance Orbiter.
That's right.
Orbiting the moon that we believe is going to get images of the umbral shadow on the Earth from one side of the moon, and then it's about 113-minute orbit. It'll orbit around to the other side and take another picture. So we're going to get a lot of interesting images of the eclipse.
And we also have two NASA spacecraft, WB-57s, that are flying over and through totality to get some measurements.
Two aircraft that are going to be flying at high altitude, about 50,000 miles. I'm sorry, that'd be too far. 50,000 feet.
Right.
Right. Flying at 50,000 feet. They're going to be getting images of the eclipse, and they have other experiments they're going to be doing. One of them is an infrared observations of the surface of Mercury.
Right.
So we're anxious to get those images in as well.
So if you can hear what's going on, we have the inside the stadium. It's rocking. We got the band playing inside, and we got a lot of music.
Oh yeah.
People
excitement is building.
It is because people are now starting to take positions. I mean, it's like I said, we're less than 30 minutes now. People are kind of scoping. The clouds are coming over. It's getting a little bit darker. So I think I can't wait. It's gonna be awesome, isn't it?
Oh my goodness, we've waited 3 years for this. Both of us, Chris.
Right.
And this is kind of the crowning moment. This is our Super Bowl Hail Mary touchdown pass.
Right. So right now, we can't go to the scope images because there is a cloud over the sun right now. It's blocking the sun. So we can't see the hydrogen alpha, the calcium K, or the white light. That's the bad part about these telescopes. If it's thick cloud cover, we can't see it.
Well, it's patchy clouds, fortunately.
Yes.
There's a lot of clear blue sky here. So I'm confident that we're going to see totality, and it's going to be amazing.
Got another question for you. It's from Paula in West Lafayette. Without awareness of the eclipse, when will it be noticeable to the naked eye? So if you're just a passerby walking in totality, doesn't know anything about the eclipse, doesn't have a TV, and they look up in the sky, when will they know?
Probably if you're in the path of totality and you didn't know what's coming, you're just going about your daily business. you might start to notice a degradation in light at about 90% coverage.
Okay.
And from there, it starts to get darker fairly quickly. When totality comes, it gets darker real fast. And of course, then it'll be obvious to anyone.
Right. Very good. Yeah. Another one from Juneau in Wisconsin. What makes Carbondale a good place for viewing?
Carbondale is a good place for viewing primarily because it has the longest duration to view the totality, about 2 minutes and 38 seconds. And it depends a little on where you are in Carbondale. You can back that up by a second or two, or maybe push it forward by a second or so.
Right.
So that's really the wonderful value of Carbondale. But we have this great partnership with Southern Illinois University, who has all this infrastructure, the stadium programs, the carnivals, all of this that's happening for people who come and watch the eclipse here. So that's another real benefit.
And we have another question. This is your question right here. Okay.
My question.
I say this one just for you. This is from Ben on Twitter.
Okay.
If the solar eclipse is a sign for the apocalypse, how has humanity survived previous eclipses?
Yeah, it's hard to know how humanity has survived to this point, given all the wars we've had. Of course, it's not a sign for the apocalypse.
Right.
I know people who think that. I went into a Walmart the other day and asked the teller, "Hey, you know about the eclipse?" Because I'm always talking the eclipse,
right?
You know, right? And
you called it eclipse hacking, right?
Eclipse hawking.
Oh, hawking, yeah,
hawking
yes.
the eclipse.
Yeah.
He said, "Oh yeah, I know about it." I said, "Oh, that's so great." He said, "Yeah, something about the end of the world." So it's just not. That's just not going to happen. Just like it didn't happen with the Mayan calendar.
Right.
And 2012, it's not going to happen. What is going to happen is we're going to have an amazing physical science event, an amazing natural event that we are so fortunate to be able to see here in the United States.
And the cool thing about Carbondale is that 7 years from now, I believe in April of 2024, they're going to experience another eclipse.
That's right. There's another total solar eclipse that crosses the United States, comes up from Mexico through Texas, through Carbondale, Illinois, out through New York and New England. And on April 8th, 2024, there's going to be another total solar eclipse.
Right.
Now, that's going to be a little different. Totality will be longer,
okay.
About twice as long, about 4 minutes and 30 seconds. The center point of the longest duration for totality will be in Mexico.
Mexico, okay.
So we're going to be there.
Right.
And you're going to be there with us, right?
I'll be right there with you.
Okay.
But the path is also different. It's not coming west to east like it is now. Isn't it from south to north?
It's coming south to north.
Okay.
From Mexico through Texas, and then up through New England and Canada.
Very good.
Yeah.
But I tell you what, Lou, like I said, we're less than 30 minutes away. Make sure you get your glasses. You're going to stay with me because we're going to throw it to Franklin, who's with Troy. And Troy's going to share some of his experiences. He's been to 2 solar eclipses in the past, one in Turkey, one in Micronesia.
Right, I got a lot of catching up to do.
Absolutely. Hey, Franklin, take it away.
Hey, thanks a lot, Chris. Yes, I'm here with Troy Klein, who has climbed out of the social media area to spend a couple minutes with us. Before you got over here, Troy, we were looking up over into the clouds. With the thin clouds, you were actually able to still see the eclipse, the partial eclipse at that time. But now we have the clouds that are totally covering the sun, and right now none of our telescopes can get anything, so we don't have any views for you right now. But as Chris said, this is not your first rodeo.
It's not.
You've experienced a couple of total solar eclipses. First, talk to us about the one in Turkey.
Oh, wow. I have to tell you, in 2006, I had the opportunity to go to Side, Turkey, and we were inside one of the ancient Byzantine amphitheaters. And that's where we set up our cameras with Exploratorium and crew at that point. And I was doing podcasting for the first time, and I was walking around just talking to people about their experiences, what it was like to see an eclipse. And we had just hundreds and hundreds of eclipse chasers. And I was thinking, I've been in different types of lunar eclipses and partial eclipses. I'm like, these people seem a little crazy. It can't be all that. It might be nice. But then when totality happened and went right over us, it was one of the most awe-inspiring things I've ever seen in my life. People were screaming and cheering and yelling, and many people were crying. They were overcome with the emotions of it. And I could understand it when I saw why people were so emotional. Because what's happening is right at about this point where we are now in the phase of partiality, we're probably around 85-90% coverage right now. And it's at this point that you start noticing visually that the sky is darkening around us. So even if there is a little bit of cloudiness here, it will get very dark here in just a matter of minutes, and probably in the next 20-30 minutes we'll see some serious darkness. But when I looked up in Turkey and I saw Bailey's beads, which are where the craters of the moon are letting little bits of sunlight poke around the edges of the moon, and you can see that with your solar glasses, of course. It's beautiful. It looks like an amazing diamond necklace in the sky, surrounding the darkest black hole in space you've ever seen. And then as that goes away and totality begins, for just a few moments, all you see is this inky black spot in the sky. But within seconds, the corona will just start to just whoosh out from the sides of the sun. And in Turkey, we saw a corona. It's a different shape every time. And in Turkey, the corona had like 2 or 3 helmet streamers, which are these beautiful, long wisps and spires that almost look like some of these really cool architectural windows you would see in a cathedral or a church. But they were coming out from the sun, several solar radii. And right after that, I started noticing little twinkles in the sky. And as the sky grew darker, I saw planets and some of the stars. And that just made the emotional experience even more. And then I noticed my skin was cooling down. And the temperature had dropped 10 degrees in that short amount of time. People were screaming and yelling. And then at the end of it, you start to see a little bit of the sun peek right around the limb of the moon, and you put your glasses back on and you experience everything in reverse. That was overwhelming and amazing, but I also had the opportunity last year to go to Micronesia, a little tiny island, a coral island called Waliai, and that's in the South Pacific. It took us 5 days to get there to do the webcast that we did last year, which is...
Hold on, I'm going to shut you down. 5 days. Tell me a little bit about how you got there. What airline and ship did you take to get there?
Well, it took 2.5 days on several flights to get to the island of Palau. And then when we were on Palau, we were able to jump onto a diving boat, and there were ferry boats and fishing boats that people were taking to different islands. But our boat it would hold maybe 20 people that you could sleep inside and eat. And so for the next 3 days, here we are going across the South Pacific on waves that were higher than this tent or this building right behind me, and it was throwing us around. So the entire time you couldn't walk. You had to hold on to the walls and the ceiling. And when I first got on the boat, I noticed there were bean bags everywhere, and I thought, well, how cheesy is that? You know, what, can't they afford real chairs? Turns out that's to catch you as you're being thrown across the boat, and you land not on the floor but in a bean bag if you're lucky. And so that took us a little bit of seasickness, a little bit of Dramamine. We finally, after the third day, we got to Waliai, and it looked like a little tiny picture of Gilligan's Island popping right out of nothingness in the ocean. And we parked our boat and docked in a lagoon, and it became super calm.
Then you got to the Eclipse. We're down to about a minute left.
Well, actually, when we got to the Eclipse part, we took our boats right up on shore on these little boats with all the equipment. And the indigenous folks of the island took us out to a runway, an old World War II runway. And we got to see totality happen for about 3.5 to 4 minutes. And it got so dark, Franklin, it was dark enough there that for people 2-3 feet away, it was hard for me to make out the features of their face. And the corona that time was beautiful but more even in structure. And then I did see about 3 or 4 planets at that point came out and a few stars. And that lasted for a while. People were screaming and yelling and having a great time. And then don't forget to look at the horizon during the totality, because it'll look like a 360-degree sunset. And I'm noticing, even though we have a cloud above us right now, I'm noticing the sky is actually darkening way beyond what this cloud should be doing.
Yeah, I can tell the temperature has dropped drastically.
Yes, it is.
I know we have some cloud cover, but a lot of this has to do with the sun being covered by the moon.
That's right. That's right. Yeah, what we're seeing now is a combination, but as I look out to the other parts of the horizon, I'm noticing that the sky is getting very dark right now. We have a countdown.
Oh, what we have some announcements being played through the public service system here. But Troy, thank you for being with us this afternoon. I know we are in the countdown to totality, so we do not have any of the scopes up right now because of the cloud cover. So right now we are going to take it back to Chris, who is on the main stage. Chris?
Hey, thanks, Franklin. And just to let everyone know that siren that you heard, there's nothing to be scared about. That just to let people know that totality is approaching. To get your Eclipse glasses ready. I know we do have a little bit of cloud cover right now, but we're hoping that one cloud that's here in the sun will actually move off because it's clear right behind it. So
Still patchy clouds.
it is still patchy clouds.
That's we hope.
Yeah, we're not that far away.
Yep.
What do you think?
10 minutes.
10 minutes, yeah.
Yeah, it's the anticipation is building. People around here getting themselves ready for viewing the totality.
That's right. So before we actually talk about some final preparations for totality, we've got a few more questions from our fans. And I think we've pretty much answered this one earlier in the program, but for those maybe just joined in, from Alexandra in Milwaukee, will it cool down during the eclipse?
Well, I hope so, because it's been very warm here. But yeah, I think we can feel even now the temperature dropping and cooling down, and that's not to do necessarily to the cloud, but actually to do with the fact we're getting so close to totality.
And one of the things that we're going to do as we get close to totality and during the totality, that our cameras, I mean, we're not changing, we're not going to have auto iris. We're going to let the viewers, if you're outside totality in the partials, you'll be able to see just how dark it's going to get here.
Yeah. It's going to get about as dark as a full moon. Brighter stars will come out. You'll see Regulus, Arcturus, I think Canis Major, Sirius, is I think.
What about planets? What do we see?
Planets, Mercury, Jupiter, Mars, Venus, all will be visible.
Yeah, and it's brilliant to be able to see those along with a total eclipse at the same time, and it just happens to be where they are.
So I'm assuming there's a lot of amateur astronomers and professional astronomers that are around that maybe have, of course, they're looking at the eclipse, but they also have one or two telescopes looking at the planets as well.
Yeah, and that's a wonderful time to do. Can you imagine the image of getting that and putting that together? And of course, it allows you to see those alignments, and it's a wonderful example of our solar system, of the planets of which we are sitting on one, traveling around this star.
You bet. And of course, one of the most famous eclipses in history, at least from a science perspective, in 1919, when Sir Arthur Eddington viewed the apparent minute changes in the position of stars as their light went near the limb of the sun during totality. Verifying Einstein's theory of general relativity.
Very cool. Now, this is kind of, I may be able to stump you on this one again, because we tried to stump Blue earlier.
Okay.
How far will the sun be from the moon? So, and it's in the moon's rotation around Earth. Where is it located? Is it more near perigee or apogee?
It's closer right now. It's closer to perigee. Perigee being the closer point in its orbit. And the question was, how far will the moon be from the sun? Well, the moon's about 243,000 miles from the Earth, and the sun is, on average, 193 million miles.
93 million miles
from the Earth. So subtract 250,000 miles.
Right. Very good. Do the math out one in your head. This is a really good one. So, can you see solar flares during the eclipse?
Possibly, though the sun is at a very minimum activity at the moment. But yes, technically, if there was a flare that was going off, if there was something that really allowed you to see the edges of an eruption.
All right.
It's happening.
I have to interrupt you because
the winds are picking up.
The winds are picking up, and maybe the cloud's moving off. So we may get totality.
Goodness, it's happening.
So here's what we're gonna do.
Yeah.
So as promised,
it's not total yet.
We're actually gonna go. We're gonna go to telescope feeds if we have them.
Yep.
All right. And then we're gonna go ahead and stop our broadcast in terms of interviews. Let the people experience. Get ready for totality.
Yep.
Get your glasses. Get your snorkelers, your telescopes. Watch totality, and then when we come back afterwards, we're going to want to get the crowd reaction. Get your reaction, Lou, Robert.
Absolutely.
I want to see their expressions on your face when you see it.
You can feel the atmosphere of the crowd right here, night. Let's go for it.
So if you're watching the show outside totality, hey, stay here because you're going to see the skies darkening. You'll see the totality in its entirety, and it's going to be wonderful to see on TV, especially with those telescope views. And we'll be back as soon as totality is over. You're watching NASA Edge.
welcome back to everyone after we just witnessed the eclipse. I'm here with our resident experts here, and Lou literally just flew onto the stage after having grabbed, I think, a successful photo. I didn't even get a chance to see.
That's right, and I remember, Blair, you wanted superpowers from this eclipse. I literally flew onto the stage.
He did.
That was so amazing. Oh, my goodness.
Yeah. So give us a little bit of a play-by-play. We'll talk with you first, Robert.
Man,
Tell us about the experience.
I watch these movies and adventure movies and suspense movies. We were holding out there because the cloud is just coming over, and then for the last, 25, 30 seconds, we saw the total eclipse. Absolutely amazing. It erupted. It was amazing. It was unbelievable.
It was great because there were a few fits and starts where the clouds almost broke and cheers, and then but wow, when it broke through, Lou.
You know, I'd lost track of where behind that cloud the sun was.
I did
and
too.
so I was thinking we're doomed. It's not. We're not going to see it. And then the crowd started yelling. I started looking up. We got about 5 seconds, maybe 10 seconds of totality.
Yeah.
That's enough.
Yeah.
That meets requirements.
Yeah.
I am now an eclipse veteran. Woo!
Yeah, and I tell you, Lou, it was and Robert, it was amazing because the clouds actually obscured the view. At times, it caused me to look out across the crowd, and the nature of the light was unbelievable. It was kind of an eerie, sunset-esque kind of feeling.
Very spooky, I suppose. Yeah. One person said, and it was like twilight, but not twilight. It was sort of, you felt it was different. You felt there was something unnatural about what was actually going on, and people responded to that. And particularly when the total eclipse was actually seen, then it was like flipping a switch, and people just erupted.
Yeah,
amazing.
It was great. It was amazing. Good experience, and you can tell even now. It's looking around. It's still not quite back to normal, but a lot of great excitement. Clearly.
And Blair, as the sun would come out and then it would go back and it would come out and go back behind a cloud, you could hear everybody yelling. This was an experience that was shared not only by everyone here in Carbondale, but through social media and through this webcast and so many other things all over the world.
Yeah.
It really was fascinating.
Yeah.
Okay, so what we're going to do now, we've talked about the eclipse, but Franklin and Kevin both experienced it, so why don't we go right now to Kevin, who's in the stadium, giving us a little bit of a feel about what the eclipse light was like for them in the stadium, because we were outside. It was a very different feel.
I think it was like this.
Totally different inside. Let's go hear from Kevin, who can give us an update on just how things went inside the stadium. Kevin, if you're available, let us know.
I sure am, Blair. Yes, it was gorgeous to me. I have never seen light so brilliant then. Of course, we had the little cloud mishap, but it was a once-in-a-lifetime amazing thing. And with me now are two people who were among the 15,000 people that was in here in the stadium. Who are you, and where are you from?
Yep, Jose Solis, and we're from Chicago, Chicagoland area, suburbs. Made the trip about, 6 hours down here to Carbondale, so we're pretty excited to be here.
Sure. Are you, by any chance, SIU students?
Yes, I'm a student at Elmhurst College. Currently going to be a senior this year.
And you're wearing a NASA shirt. I assume you'd like to work in that field one of these days?
Maybe one day, yeah.
All right. What did you think of it? Unfortunately, we had the clouds, but give us your impression.
Yeah, we had a little cloud cover. Kind of got nervous for a little bit, but the clouds moved away for just a few seconds, and we got the totality experience for probably maybe 10 seconds, and it was incredible. I had goosebumps, crazy emotions. It was awesome.
And you?
It's just crazy to experience this with so many different people coming from different backgrounds, and I'm just really grateful to be here and to be alive and just to live.
Very well said. Thank you so much, and good luck with your careers.
Yeah, thank you.
Thank you so much.
And, when you look at this broadcast, what you have to realize is there's a lot of people behind the scenes. So right now, I'm going to have the students that have been up. Jacob, come on up here. And Eon, this is a guy that you'll see in just a few seconds. He's wearing a blaze orange shirt. He is the one that's been behind the camera. They have been working hard all day bringing you these good videos. Jacob, briefly tell us a bit about yourself.
I'm a student here at SIU, majoring in physiology with a minor in chemistry. I'm on the pre-med track, and I'm going into my senior year.
Nice. All right. What did you think?
I thought it was incredible. The clouds were a little bit disappointing. We did lose a little bit of totality, but it really added suspense. You could tell people lost it when it finally fully eclipsed and it was fully there and the clouds broke. It was great. It was awesome.
All right, thank you very much. We'll get another comment here in just a little bit, but right now I'm going to throw it back to Franklin.
Thanks a lot, Kevin. I'm here back with Autumn Burdick. Autumn, that was our first total solar eclipse. What are your thoughts?
That was so cool. And to be in there with the crowd and watching their reactions. Okay, so the clouds added a little bit of drama to the day, I have to say. And when it opened up and we got those moments of totality and we were able to see it without our glasses on, that was awesome. It was just like the winning touchdown or basket in a game. It was such a surge of energy. It was so cool.
That was exactly what I was going to say. Yeah, that was the Hail Mary at the end of a game. That is the zero time left on the clock, and we actually saw totality, if only for a couple of seconds. It is something that I'll never forget for the rest of my life.
Right. No, it was very cool. Very cool. And remember, use the app, the Globe Observer app, to make other observations after the eclipse, measure those clouds, and do some mosquito habitat monitoring.
Mosquito habitat monitoring? Wait, you know what? Do you really think you're going to get a lot of observations directly after totality, with people just looking up in the sky amazed?
Yeah, you can still make those observations for these 2 hours now of the temperature, because the temperature is going to rise now as, the sun and the moon are finished doing their dance. And then we will get that data and see what types of effects the eclipse had on the atmosphere.
Sounds great. Autumn, thanks for being with us today.
Thank you so much, Franklin.
All right. Right now, we are going to send it back to the main stage with Mr. Blair Allen. Blair?
Thanks a lot, Franklin. Again, we're here with Rob and we're here with Lou, and I got to tell you, I'm done. I'm sitting here basking in all this, and of course hearing all the reaction. Just amazing. Now, you were with your family, Robert.
Yeah.
Tell us a little bit about how their experience was.
Oh, well, I've never seen an eclipse before. We've traveled from the UK to be here. They were hoping the clouds were there, and then when we saw it was my daughter more than anything else. I've seen an eclipse. It's there. Just the expression, the exuberance of what that actually means, and that's just one of many, many examples around here in Carbondale today.
Absolutely, absolutely. Now, and from a scientific standpoint, when we saw it, all I could think about was you talking about the corona and everything else.
Well, for me, that's very special, because I look at the corona day and daily, but from NASA satellite imagery, and I know what the corona looks like and that sort of thing, but to actually see it with the naked eye, to actually see the area which I've spent my life trying to understand and try to untangle the mysteries of the corona, there to see it before me, without a computer screen, with any artificial, just me and the corona looking at each other, was I can't describe it really, it's amazing.
I like the way you said that, you and the corona looking at each other, that's great. Lou, talk to me.
Well, I was here with my 3 daughters, all just kind of standing in a line over here, watching, waiting, hoping, praying almost, please come out, son.
Yeah.
And this is their first view of totality, and we were all yelling and screaming along with everybody else. So we did high fives all down the line. So it's a really special moment just to share it with my daughters.
It's one of those things we'll talk about as a family for the rest of our lives, really, isn't it? And that will be repeated thousands of times, not just here at Carbondale, but across the country. They will remember, as part of the family heritage, seeing a solar eclipse.
And that's really true, and it's interesting because as we think about reflecting on what we just saw, thinking about our friends that are further down the path that are about to experience or experiencing even now, when you've seen it, you can relate a little bit differently, you know, and that's just an amazing thing. So I don't know how we're going to unpack this in any kind of meaningful way for the scientific community. Right now, I feel like the emotional community is the only group I can really help at this point.
It's going to take some time to come down off this high, that's for sure.
Yeah, no, absolutely. Though there's a lot of science going on, just experience it, just being there, just understanding where you fit and how you fit in the universe with seeing something like this is probably at this stage more important.
Very well said. Now, we had a chance to talk to a fellow friend of ours at NASA Goddard Space Flight Center, Matt Gopalswamy, and he did some scientific measurements during the eclipse earlier, but we talked to him about that whole process leading up to that. Let's check that out.
So Nat, you're an astrophysicist, and you're going to be studying the lower corona during totality. Tell me a little bit about your research.
Okay, so we are going to observe the eclipse during the totality. We will be measuring the shape of the coronal spectrum, and the changes in the coronal spectrum gives us information about the temperature and flow speed of the corona. And this information is useful to understand the origin of solar wind near the sun.
Now, can you get the same data from using coronagraphs?
You can, except that in coronagraphs you don't go close enough to the sun, because you've got to have an artificial eclipse that is produced by an occulter. And this normally works better for some certain distance from the sun. And the moon is a perfect occulter because it can go all the way close to the surface of the sun.
Now, will you be able to collect this data during the total part of the eclipse, or will you still be able to get data as you're approaching the total eclipse?
We can get it only during the total eclipse because the corona is not visible. Even a little bit of 5% of the sun is showing up. You cannot see the corona. So you have to have complete totality. That is the second contact, we call.
Now, you're going to be doing this research where?
In a city called Madras. This is in Oregon. This is right on the path of totality. And according to all the statistics, that is the best place with the lowest possible weather effects, cloud cover and so on.
What can this data be used for? What will you be able to use the data that you get out of knowing the temperature?
There are two things. One is actually demonstrating a technique. We have a new camera. It's a polarization camera that is specifically selected so that we can do this measurement, because we have to make measurements at two wavelengths as close in time as possible, and with a polarization camera it is possible. Mm-hmm. In the past, also in chronographs, the polarization measurements requires placing a polarizer wheel in the path and rotating it 3 positions, and that takes time. So the first wavelength and the second wavelength are not measured simultaneously. Whereas with the new equipment we have, we can measure them simultaneously. And this greatly improves the sensitivity of the detection. The important thing is, once you demonstrate this, then we can put a camera like this in space. Then you can actually measure the temperature and flow speed over a much bigger field of view, which chronographs are interested in. So it is more like a stepping stone for using in space.
Hey, we're back live. Sorry, I have a little mic issue. I was so excited that
he lost his mic during the eclipse.
I lost my mic. I'm trying to get back on.
Hidden by the cloud.
Our producer's probably
well, I'll tell you what,
saying a few words right now.
While you work with that, it's
okay.
Just interesting with Nat's piece. They're talking about temperature readings. I'm sure he got temperature readings today, and it was cooler during the eclipse. Certainly felt the temperature drop. It's starting to warm up a little bit now that the sun's coming back out.
You know, the thing that got me as a first time, I guess I'm a veteran total solar eclipse person now. You know?
Yeah, he's a veteran.
So you had this cloud over us, and we're sitting there. It's like, oh, jeez, this one cloud. It's clear everywhere, right?
That's right.
And it's going, and everyone's like, come on. And all of a sudden, the buildup. You can see the cloud coming through, and at the last second when it appeared, I mean, the whole place erupted, and that's all you needed. I mean,
that's all we needed, and we saw it just long enough to be able to see the corona and the shape of the corona just seconds before the diamond ring appeared.
Right. Yeah.
Which was one of the most exciting parts of the eclipse anyway, so we saw it.
And I'm really interested, after this show's over, first thing I'm going to do is I'm going to head over to that trailer.
Yes.
And I'm going to ask Brian and Steven and the guys in the Sun Lab to see if they captured it and see what those high-res images look like.
I thought you were going to say we're going to head over to that trailer and fix some eclipse martini. Yeah. I'm just saying.
Well, it's interesting because as it was covered in the clouds, I'm sitting there and I'm thinking, I'm just waiting for that announcement in the stadium to say, put your glasses back on, and I'm fearing it, and just right at the last minute opened up. I think
with
amazing.
The thousands of people here, we're able to will the cloud away with a little bit of help from the atmospheric conditions.
Sure.
But we did get to see it, and I'll have to tell you, based on comparatively speaking to other eclipses, the one in C-Day Turkey that I saw had helmet streamers, much like couple of the streamers we saw here.
Okay.
Yeah.
And so that one was spectacular. I think this one was just about as spectacular as that once we saw it.
Really?
And the one last year was beautiful, but it was more of just a normal halo of light that we were able to see. So this was extraordinary. So it was really like a nail biter. Mother Nature put us to, the movie right up to the last minute, who's going to win.
All right, so if you had to rank them 1 through 3, and the ones that you seen, what would you
This
rank
one,
them?
I believe Sea Day Turkey would be number 1. It was my first.
Right.
And it was amazing to see how big the helmet streamers were. But this one definitely number 2. And then number 3 number 3 for the shape of the corona in Micronesia. Micronesia would have to be number 1 as far as the location with the people from Waliai and being on a remote island and all of that fun stuff. But this was extraordinary. I'm so excited. My heart's still pounding. I was scared to death we weren't going to see it.
Absolutely.
That's
Absolutely.
crazy.
Now,
Well, we got a lot of social media folks, don't we?
Absolutely. Lots of things to catch up with.
Yep.
Yes.
How are people responding to the questions that
just like us right now? People are giddy and they're excited, and they're placing actually on our Flickr gallery. People are placing just dozens of pictures of the eclipse as they're seeing it all along the path. So keep watching that gallery because you'll still see people as they're uploading their images and experiences. So if you still feel the excitement in the air, it's because it's not over. It's still going on.
It's traveling across the country,
It
still
sure
going
is.
towards the East Coast, right?
That's right. That's right. Now here's what they're saying on social media.
Okay.
So we still have Eclipse in 6 happening.
I like that. The eclipse.
Yeah,
in
that's
6.
so
That's
cool. Describe the eclipse and what it means to you and how it feels in 6 words. So now we have the magnificence of nature in action, and that's from Wayward Plain. Sharing real science with our kids.
That's what we're all about right here.
It's about relationship, the sun, moon, and the earth. What a relationship is that?
Yeah, right.
Yep.
And then we sat stunned, staring above us.
Nice.
That's what we did.
Yeah.
Well, I was kind of screaming.
Yeah.
I was stunned and screaming. The moment when day becomes night.
Yeah.
The Super Bowl, but for science.
Yeah. Nice. I like that.
It'd be a science Super Bowl.
The Solar Bowl.
The Solar Bowl, right?
Yeah,
the Eclipse Bowl. And said, and this one, I think Blair must have sent this one in. Says, okay, so I cried during it.
I actually did almost cry. I really did. It was amazing.
You had a couple of drops coming down.
Yeah,
huh?
it was really profound.
Now I was trying to think of one just as I only came up with 5 instead of 6, but if you put away as 2 words, I'm good. The clouds went away.
Yeah, very good.
Yeah.
Yes,
the clouds went really away.
Thankfully. And I like we had a reaction from someone in the stadium, and they just said they were humbled by all this. And
That's
I think
so true.
I think at the end of the day, that's really what we're talking about. You planned for all this, you wanted it to happen. It may or may not. You didn't know what's going on when it hit you. It's just like we live in a big solar system, a big galaxy, and we have no control over these massive events, and they just bring you to your knees. And
That's
really
the part that really
amazing.
does ring true, is that we have no control about what's happening around us. All we're here to do for things like this is to witness it and be part of it.
Yeah.
We made everybody in our tents and everybody run outside. We stopped everything for that entire time as we willed the clouds away, and thank God it worked.
I felt kind of bad because we're watching as totality is about to hit. So Blair and I are at the front of the stage, right?
Ready to fall off.
Not paying
back
attention.
of the stage.
Not
We're
paying
just
attention at
looking
all.
up.
Yeah.
People are, I hear people screaming. You can take your glasses off.
Yeah.
So we're waiting, and then someone came up to the front of the stage and says, "Could you turn the lights off?" Because we had our stage lights on.
And just people cheered when you did.
Yeah, I know.
They did. Everyone just started erupting. I'm like,
When we noticed even the lights on some of the buildings behind us came on automatically.
For the
during
emergency.
eclipse.
There were certain lights.
There were certain lights. Yeah, they said SIU said they worked really hard to get, and you could tell most lights that would come on at that time were not on, but few
It
for safety
definitely wasn't as dark here as it was in Micronesia.
Really?
It got so dark I could hardly see faces of people. Here it got dark, and I did see 2 stars, a planet just up over to the stadium.
Yes.
And the clouds covered a few others, but they came out. They were pretty bright when we saw them.
And I'm glad you brought that up, Troy, because it was really interesting. Because you could hear in the crowd people cheering certain things.
Yeah.
I saw stars. They were identifying them as they saw them, and
they want everyone to know.
It's just you can't help it. You share it, and
friends of mine noticed something else, and this will be good for a friend of ours, Trey Winter, who's doing soundscapes for people who are visually impaired to be able to experience the eclipse through sounds and what the animals, crickets, and things are doing. Soundscapes for people who are visually impaired to be able to experience the eclipse through sounds and what the animals, crickets, and things are doing. And so I'm excited to see what data they get back from that. But while we were standing just over to the left of the stage, we actually heard the crickets come out. They were chirping like crazy.
That's great.
Yeah, it was just happening just over to our left. And they're quiet now, so I don't hear them anymore.
What really got me is, man, it's so bright now. I mean, compared to what it was. It's amazing it's amazing how fast it happened.
It is. It was very, very fast, just 2.5 minutes. But we were looking at a cloud, as it got dark all around us for a bit of it. Did you notice the horizon?
Yes.
Yeah.
Yes. We noticed on that side, too. On both sides, yes.
You couldn't help, and I was telling Chris, it looked like sunset all the way around.
It really did.
It's amazing.
It really did.
It's
I'll be curious to see the people who are on the roof of the stadium viewing it up there, what kinds of pictures they might have gotten during that experience.
Oh, well, you would have sort of sunset kind of
360
all the way around.
Oh, yeah, it's amazing to do that with a panoramic camera when you're in that position.
Wow.
So for those people who haven't seen Totality yet,
That's right.
we really encourage you to be in a place where you can see the entire horizon and try to get a nice pan picture of that for us and post it to our Flickr gallery.
Please.
We'd love to share that out.
And while they're getting ready for Totality on the East Coast, you got some more songs from poll question number 2.
We did. You know, what song, if you could listen to any song during Totality, unless you want total quietness, like some of us do, what song would that be? So here we go. Number 1 was Space Jam theme song.
Okay.
So that makes sense. Blinded by the Light.
Blinded by the Light,
nice.
yeah.
That makes sense.
Which version would that? I'm sorry.
This was the what
Bruce
do we have?
Springsteen or Manfred Mann.
There we go.
Gotcha.
They actually said that. Bark at the Moon. Ozzy Osbourne. Of course,
He's playing here not that far away.
He was supposed to play during Totality.
Maybe he barked at the clouds and they went away.
Yeah.
Maybe
It could be.
We have Dancing in the Dark by Bruce Springsteen.
I love that. Yeah.
Black Hole Sun.
Yep. The Soundgarden. That's right.
And of course, Total Eclipse of the Heart. Bonnie Tyler.
We won't get
and,
the versions there.
The Dark Side of the Moon.
Yes, Dark Side of the Moon.
Those are our winners so
Good
far.
call.
So people are going to still post, and they're still posting Eclipse in 6 for us.
And do we have a final question?
We have a final question for today. We have question number 3.
Oh, yes, we do. Thank you very much. I had to think about that. I'm still thinking about that last moment of Totality. Wow. So here's question number 3.
Yep.
If you could view an eclipse or transit from anywhere else in the solar system, where would it be?
Wow.
Interesting.
That's interesting.
Yeah.
And people have asked, is it even possible to view an eclipse from another planet or transit from any other planet in our solar system? And the answer is pretty interesting. So let's see what you have to say about that.
I already have an answer.
Yeah.
You do?
Yeah, I have one already.
Okay.
2084. As Lou Mayo said it earlier,
That's fair.
if you're on Mars, you can see the Earth transit
You know
across
what?
the
That's
sun.
actually possible, isn't it?
Yeah, it is possible.
We might have somebody on Mars by then.
Wow.
That's the cool part about it.
That is so cool. Want to
And,
go?
and they won't be shooting it in 6K. It would probably be like 32K or
Yeah,
50K
oh
by
my
then.
gosh.
Yeah?
64K.
64K.
You
Yeah.
know, hyperspace streaming or
Yeah.
something so we can see it on Earth.
Yeah.
So let's see if we can
Let's
go back
do
to the telescope feed, because I think the clouds are definitely gone.
Oh,
Look at that.
look at
Oh,
that.
wow. Look at this. Look at this, Troy. We got hydrogen alpha. The moon's coming back. We see that active region that's starting to appear again.
Yeah, the sunspots are beautiful right there.
Oh.
It's amazing imagery.
See, this is a good time if we had a CME coming off the sun there on the right-hand side. That would just be that
Well,
would just be
what
good.
I really love it. Some people they take the data and sonify the data. And I was listening to that through some friends of mine when we were in Micronesia. And they actually, the light was part of it, shadows, cloud movement, bird movement, all had a different symphony instrument. And it played its own nature and natural orchestra. It's really, really beautiful. We should share some of that online.
Absolutely.
Awesome.
Well, I tell you what we're going to do is we're going to enjoy these great telescope feeds for the next couple minutes, and we'll be back. You're watching NASA Edge.
An inside and outside look at all things NASA.
I was going to say that.
Oh, you should have.
Brian Stevens from Lunt Solar Systems. Brian, we got totality for about 6 seconds. We were playing with the hand that we were dealt. What were you seeing, inside the Sun Lab?
Well, we saw something pretty much similar to what everybody else did. We just saw a magnified image of that. It's a game of processing now to try to get something out of that, because it's a very big light shift for during the entire time, and we didn't have much time to get everything exactly the way to that correct filtering. We'll see what we come up with. Hopefully something terrific. That'd be terrific, wonderful to do.
Now, when the sun was behind the clouds, I know the heliostat tracks it. Is it able to work with behind the clouds, or you have to actually manually control it at that time?
It's misbehaving a little bit today, so we've been manually controlling it quite a bit all day long. Just kind of went in the same direction we've been going through during when it was behind the clouds. But it's supposed to track typically on its own the entire time without any interaction with anybody.
No, I know. I saw the door open up during totality, because I was looking back and forth. You guys were jumping out. Brooke jumped out. He was looking up in the sky. Steven came out, and I was looking back and forth, and I saw the monitor, and I saw the Corona in just one shot, if only for a second.
Yeah, it was up there a few seconds. Yeah, so we'll be working with that as best we can to try to snap that out as possible.
I'm not going to say we're going to get an image before the end of our show, but we definitely, when we get what we get, we will have it on NASA Edge, on the NASA Edge fan page, and put it out there on Twitter and on our social media feeds. Brian, any other final thoughts for today?
No, just continue to wear those glasses till it's all over.
Yes, we are in a partial eclipse at this point, so everybody out there, you want to continuously, safely watch the eclipse. Right now, partial eclipse until it's over, no staring at the sun. Right now, we're going to send it back to the main stage.
Hey, thanks, Franklin. We're being joined now by Bob Baer, who is you're the Eclipse co-chair for SIU. Boy, I tell you what, Bob, what a tremendous event you guys have put on here.
Yeah, this was wonderful, Chris. And I'm really glad you guys could make it here for this. That was amazing.
And I got to get your reaction, because you were in Micronesia last year for the Eclipse. Tell me, share the experience between Micronesia and this one here.
This was different. This was different because we had that cloud, and we saw the diamond ring. That was awesome. So as soon as the diamond ring hit, I was behind a telescope down there, behind a pretty good white light telescope. I got to see a little bit of Bailey's beads,
right,
and I got to see the start of the corona. That was awesome. And then the cloud came in.
Right.
But inside that stadium, I mean, you would have thought that we were going for the winning touchdown. People were pounding on the stands, just yelling for those clouds to get out of the way. At the end, they did. And we saw the diamond ring at the end again. So we had the start of it, the end of it. Those were the best two parts.
Right.
And then shadow bands. I don't know if you heard, we saw shadow bands in there.
Wow.
So we had white tarps out on the field. We had the Girl Scouts set out 8 white tarps with our Society of Physics students here. And while they were sitting there, Michelle Nichols was walking around talking about look for this, look for that, and they showed up.
Now, what are shadow bands exactly?
Well, it looks like ripples of light or shadows on the ground just before, just after totality. Okay. And some people call them snakes. It looks like snakes going across the ground. And it's from that last sliver of light coming through the atmosphere. It's kind of like a light from a spectrometer that you'd see. And so it tells you something about the atmosphere. So we had 8 tarps, and on 2 of them we had markings, and we had our Society of Physics students running video on those. So we might get some science out of this, I hope.
I tell you what, I have to agree with you, because this is my first total solar eclipse, and had that one cloud was there. Yeah. So we were just hoping, and you're right, the buildup was there. It felt like it was the fourth quarter of a football game. You're in a 2-minute drill, and then you're throwing that Hail Mary pass, or that last pass of the game, and you get the touchdown, boom.
That was it. It was only a few seconds of the first diamond ring, only a few seconds of the last. We got data, though.
Did you?
So, yeah, the last thing I said as we ran out of the stadium was back up the data. And we'll see what that looks like a little later.
Now, I just got to switch focus here, because I know this has been more than a year in the working for you, to plan this event here at SIU.
Oh, yeah.
I mean, just kind of give a sense of the viewers that are watching, all the planning and the prep to make this happen today.
Wow. Well, 3 years ago, I think I met Lou Mayo at AAS Eclipse 2017 conference, and we talked a little bit there just informally. Gosh, I think we went through a few different groups. You know, the Eclipse Observers Working Group. You guys were Sun Earth Days team, if I remember right.
Right.
And then morphing into the Eclipse 2017 team, and big changes on campus from a few people planning to 80 people planning to now. This is everybody on campus out for this.
Right.
All the athletic staff. Right. The planning was monumental, but it paid off. This was awesome today.
And also, too, is, I mean, just the record crowds here, the stadium, the people are walking all over campus. I mean, the logistics was monumental for you guys.
It most certainly was. We're running multiple venues here today. You know, we have the stadium, we have the arena, we have the art and craft fair, we have people in the open areas here today. So 5 venues over 4 days, a carnival that's still going on. Yeah, big undertaking.
You know, and we've been here since I think it was our 3rd time here, and just to see the progression over the past year, it's been amazing. You guys have been such a tremendous support. You put on a great show here. But I tell you what, it was worth it. You're absolutely right. When those crowds went through and we saw totality for what, 10 seconds, 5, 10 seconds?
Probably 10 seconds. Yeah.
It was all worth it, wasn't it?
It definitely was. That was awesome. And the cheering in those stands, that's what I wanted to see. I wanted to see it from the field and see the crowd reaction, and I got it firsthand.
And we're going to be coming up to you a little bit later, hopefully, or maybe your counterpart with Citizen Kate. We're going to learn all about the citizen science and hopefully the data that you got all across totality.
Yeah.
That would be amazing.
68 sites across the country. I can't wait to see that.
And so I just, I don't say, I mean, I'm lost for words. You're right. It's incredible. Just the magic that you see in the sky there.
Yeah, I wish I could have taken a picture of what my eyes saw through that telescope, but I'll settle for what we got on Kate.
Now, what are you going to do from here? I mean, where do you go next?
Oh gosh. Let's see, debriefing, planning for 2024, figuring out what to do with, not figuring out with, but the Kate team analyzing this data, the larger scientific community analyzing the data coming from across the country right now. There's a lot of work to do.
Right. 2024, crossroads of the eclipse. Can you make it any better in 2024 than now?
Well, I don't know. Possibly bigger. This was a pretty big one, though. But yeah, I'm really looking forward to trying.
Now, what's totality going to be like in 2024 for Carbondale
Oh,
compared to now?
it's about 4 minutes, so it's longer. I don't know the number of seconds on it, but we're not at the point of grace duration for that one. I believe it's down in Mexico.
Yes.
And the path's wider, the shadow's larger.
Right.
So totality's about 4 minutes for that one, as opposed to our 2 minutes and 38 seconds here.
Wow. So you're going to be coming back later in the show. We're going to be talking about Citizen Kate, and I know you're probably sweaty and excited. It's hot out there in the stadium. I mean, you've been out there all day, haven't you?
Yeah.
How's the crowds been?
Well, initially, we were looking around and it's like, where's everybody at, guys? Come on. Oh my gosh, they filled in. I think that looked pretty full at totality. But a 5-hour show, people showed up at the time they needed to show up for the balloon launches, which were awesome. And then totality. It was, like I said, it was loud in there. Everybody was excited.
Well, I think you need to go cool off, get the sweat off your face, get a Gatorade, get some water, and we'll have you back later on the show. But what we're going to go now is we had a chance to sit down with a solar scientist from NASA Goddard Space Flight Center, Yadi Colada-Vega, and she's going to talk about how we can actually do some visualizations with the sun. Let's check it out.
So, Jadi, you're a space scientist here at NASA Goddard, and you study the sun to understand space weather. How do you do that?
We actually study the sun in many ways. We use missions that are outside in space, like the Solar Dynamics Observatory, to look at the sun's surface and know where in the sun's surface they're creating those solar storms that actually create what space weather is. But there's another type of instrument that we use, like a coronagraph, which is an artificial eclipse. And we do that because we have to block the sun to be able to see what everything that is coming out from the sun. And those will be the big explosions of particles from the sun's surface that we call coronal mass ejections, or CMEs. The coronal mass ejections, then we analyze them. We inputted the parameters in another model that we have, where we actually use magnetic field on the sun's surface to actually see how the solar corona is expanding. And that model permits the CME to be ejected from the sun's surface, and then we can actually know when and where the CME is going to impact. But there are other aspects of space weather, like the solar flares, solar energetic particle events, geomagnetic storms here on Earth, So there are many aspects of space weather that all originate for us on the sun.
Now, are you able to get data, let's say usable data then from just observing the eclipse here this year?
Yes, the scientists pretty much follow the whole path of the eclipse. So they have a whole range of the data because you can have an image, and that will be amazing to have the image and to see all those inner parts of the corona and the prominences on the sun. But you also need the dynamics of what's happening to understand it better. And that's why they actually follow the whole path to actually have the whole time that the eclipse happens. So they can actually have the whole dynamics of the corona.
So now, in your everyday life here at NASA Goddard, when you're looking at the sun, what kind of information are you studying to better understand what happens during these coronal mass ejections?
Myself, I'm a magnetospheric physicist, so I do try to understand that solar wind magnetosphere interaction. However, as a space weather forecaster, we actually try to understand any space weather event that happens, the solar flares, the coronal mass ejections, the solar energetic particles, which are particles that are accelerated by these processes on the solar corona, of fractions of the speed of light. And they're very high energy particles. And those are really important because we, as a NASA entity, we watch what's happening in the NASA missions across the solar system. So we do our analysis and predictions to protect NASA robotic missions. So we don't look at the sun only from the Earth-facing side. We look at the sun 360 degrees because we have missions across the whole solar system. So it's a very interesting job, and I do enjoy it a lot because we are trying to get something out of it that will protect our assets that we have out there in space. And as a researcher, I do enjoy, those instabilities that are caused by the solar storms on the magnetosphere, because that actually gives you an idea on how the magnetic field of the Earth changes, how the geomagnetic storms are evolved, how the auroras are created, how low in latitudes those auroras are seen, how the ionosphere changes. Everything is a chain of events, and everything's interesting.
Hey, I'm here with Michelle Nichols from the Adler Planetarium in Chicago. Michelle, awesome eclipse?
It was a few seconds, but it was absolute magic. I'm so happy we saw it.
I am too. And we are also joined by Miss Elena and Madeline, who are the Girl Scouts helping us today during our demonstration. Ladies, how did you like the eclipse?
The eclipse was wonderful. Even though we saw it for a couple seconds, I didn't think we were going to see it, but it was amazing.
Great, and good to hear. Michelle, we just had the eclipse. We're about to do a demonstration. Tell us a little bit about it.
All right, so we've seen a lot of great imagery about the eclipse, but we need to get a sense of size and scale because that Earth and Moon, I want to give you a sense of how big and how far apart they actually are. So I have an Earth globe here. I'm going to give it to Madeline. And so that globe is about a foot wide, all right? So I want everyone to think, how big on this scale do you think the moon is? Think about it for a sec. So those of you at home, think about it. How big do you think the moon is if we shrunk the Earth down to the size of this globe? So some of you are probably saying this big, all right? Some are saying that big. The answer is, I've got the moon globe in my pocket right here. It's about that big. So the moon is about 1/4 the Earth's diameter. So that means you could fit 4 moons across the diameter of the Earth. Now we need to get a sense of how far the moon is from the Earth. So I'm going to give this moon globe to Elena. And then I'm going to give the end of the string to Madeline. And I'm going to give the rest of the string to Elena. So I want you ladies to start walking behind us here and string it out. Hang on to it there and turn around a little bit and start walking that way. String it out. String it out. Okay, folks, how far apart do you think these are? Keep stringing. Keep going. Keep going. Except it gets tangled, which happens all the time. Yep, it's all right. You're doing good. So the Earth and the Moon are about 240,000 miles apart. So if you do the math, 240,000 divided by 30 times the Earth's diameter. Oh, there we go. That far. You can have 30 Earth diameters. out to where the moon is, and just think about the sunlight shining on that moon. How tiny that shadow is going to be by the time it reaches the Earth.
Yes, just about half of a state, some states.
Oh gosh, yes. So for 240,000 miles, how long would it take you to drive that? Going 75 miles an hour, about 4 months. If you went nonstop for the whole time.
4 months.
4 months. That's a road trip. I don't think I'd be able to handle.
Can you step back just a little bit?
There you go.
Oh, there
Check
you
it
go
out.
now.
You can see it. You show the moon globe there, Elena. You show the moon ball. There you go. There you go. See it? How small that actually is. That's amazing.
That is amazing. Great demonstration. And now we are going to go to another demonstration and tell us a little bit about it.
Yeah, so everyone at home can do this one too. So think about how small our moon is. How can it actually cover up the sun? If our moon is smaller than the Earth, how is it that the moon can cover the sun and give us a total solar eclipse? I want everybody to take your thumb out. Find something off in the distance, like if you're in an office, as far across the cubicles as you can get. If you're at home, just look outside. Find something outside. And I want you to stick your thumb out at arm's length. I want you to cover up whatever that is. Find something off in the distance. So I'm picking a light pole. I'm pretty much covering up a light pole all the way off in the distance.
You and me both.
Yep, but if we were to take our thumbs up to that light pole, our thumbs would be tiny compared to that light pole.
Yes.
So how does this work? It's because we're far away from it. So even though the moon is 400 times smaller than the sun is 400 times farther away. So therefore, it all works out.
Great information, awesome demonstrations. Michelle, before you go, tell us a little bit about the Adler Planetarium in Chicago.
Sure. The Adler Planetarium, we are the Western Hemisphere's first planetarium, opened in 1930. And at the Adler Planetarium, science is for everyone. We welcome everyone to come join us and see how fun science really is. We try to make science fun, accessible, and we try to expand the walls of the planetarium outward so you can join us in doing science wherever you are.
Michelle, thank you very much for being with us today. I'm glad we were able to experience the few seconds of the total solar eclipse, but we got it in.
Thank you so much. Yeah, we sure did.
Okay, guys, we're going to send it back to the main stage with Mr. Blair Allen. Blair?
Thanks, Franklin. I'm here with Coral Clark, who works with Sophia, but I just wanted to say right off the bat, tell me about the eclipse experience.
This was absolutely phenomenal. I know that it would have been much better if we got to see a few more seconds or over 2 minutes of that totality, but it certainly was dramatic, and it was amazing to see everyone so excited and so engaged in the world around them.
That's awesome. We had a great experience too.
Yes.
But I did want to talk to you about Sophia, which you're very familiar with.
Yes.
But the interesting feature that I noticed right away, it just makes me think of James Bond. This big 747 with this hatch that opens, and is that you have a telescope inside? Is that right?
A 2.5 meter telescope on a 17-ton telescope assembly. That hull is so big. Talk about tricked out, right? You could even drive a car through it. And when we opened that hatch at 38,000 feet to start doing our data collection, there is nothing in between that telescope and the atmosphere.
Well, it's interesting because now that door only opens during flight, correct?
That's correct.
Okay. Yeah. So I was wondering. I was like, you certainly can't take off with that open. It's a vibration and everything.
Well, it's not the vibration so much as it would the water vapor would damage the telescope. So yeah, the vibration dampening is incredible on that aircraft. That 17-ton telescope assembly is on a pressurized oil bearing. So it's balanced incredibly well, and there's pneumatic dampeners that help with that vibration and stabilization. And the laminar flow across that opening, you can't even tell when the door opens.
That's crazy. Now, obviously you have a cool 747 sort of, outfitted with this observatory. What else is on the aircraft that helps support this incredible device?
Well, we do have a bulkhead in between the telescope cavity and the crew, so we don't get sucked out, which is nice.
Yeah, that's important.
Very important. And we have a crew of anywhere from 15 to 35 that are supporting each overnight 10-hour mission. That includes mission directors, pilots, of course, instrument operators, telescope operators, and astrophysicists who have time on the observatory.
Now, I understand, and I don't understand all the details. You'll have to help me with this, but one of the recent things that Sophia accomplished was doing this Pluto occultation. What is an occultation, number one, and how did Sophia play a role in it?
Right, so that was a very exciting mission that we had. And in an eclipse, the objects are about the same size. Our moon is randomly about the same size as our sun, apparently, and it goes in front. When a planet or a moon of a planet goes in front of a distant star, the closer object, the planet, is much larger, apparently, than the star. And so when that happens, it's called an occultation. And how we saw the shadow of the eclipse here, an occultation will produce a shadow that's racing very fast across the Earth. So you have to be at the exact right place at the exact right time. It's really tricky business. And in 2015, we were able to do an occultation and got successful data from Pluto, and an occultation that happened with Pluto 3 weeks before the New Horizon mission.
Well, that's interesting. You mentioned New Horizon, because I was thinking, wouldn't that be great if you could coordinate with something like New Horizons as it arrives at Pluto and takes those stunning imagery. That had to be planned, obviously. You wanted to corroborate the data or kind of complement it, if you will?
It was. One thing I'm very impressed with working with the astronomical community and the scientists is they really do cooperate together and collaborate whenever they can. It's a wonderful facet of what NASA does.
I love it. And even today, we're seeing a lot of citizen science. We talk to people that are actually collecting data for the eclipse. So you see that extend even here at something like an eclipse viewing. But I also understand that there's a Kuiper Belt opportunity for Sophia in the near future, or has it already happened?
There was. So we did we just came back from New Zealand from our deployment there, and there was the next New Horizon object that they're visiting is Kuiper Belt object MU69, and we were able to be part of have that as a target for one of our missions in New Zealand. But what's coming up is on October 5th, 2017, this year, is an occultation of Neptune's moon Triton.
Awesome.
And we're going to be doing a lot of public engagement and social media in connection with that event, and we really want people to follow us in social media at Sophia Telescope.
Okay, I'm not going to tell you how to run your engagement community, but how about arranging some flights on Sophia, so you can get out there and enjoy the observation. Yeah, I'm perfect size to fly on a 747, and I can handle long duration flights
overnight, right? 10 hours overnight. You have to stay up. Poke you with a cattle prod if you fall asleep.
Okay, so now you're painting a different picture.
We should talk. Actually, we do bring media aboard occasionally, and we really welcome the opportunity to engage the public however we can. And we also have a program where we bring educators on board as well.
Oh, that's great. Good opportunity. Well, see, I didn't have to help you. You're already way ahead of the curve on this. That's fantastic. Yeah. Well, I tell you what, I love to hear about the things that are going on in NASA and the scientific community, and Sophia's great. Thanks for coming and sharing with us today. Right now, we're going to go to Kevin, who's in the stadium. He's going to be talking to Dr. Phil Anton about a program called Train Like an Astronaut, where you actually figure out how you can train now to be a future astronaut. Kevin?
Yeah, thank you very much, Blair. We, of course, are on the field. And in several minutes, we will let you in on the secret what these world-class athletes behind us, what they are doing. We'll talk to them in just a little bit, or we'll see how they work out. With me now is Dr. Phil Anton. And what is your title, and what department are you in?
I am an associate professor of exercise physiology in the Department of Kinesiology here at SIU Carbondale.
And of course, as we've talked many, many times before, right now we're just standing here. We're not lifting weights or doing anything, but we are exercising, right? Explain that.
Yeah, most people don't even think about the fact that when they're just standing still or when they're sitting, they're actually working out because you're resisting the effects of gravity at that time. And that's putting load onto your muscles, your connective tissue, and your bones and your cardiovascular system, and keeping those at a basic level of fitness. But when you go into space, in microgravity environment, you take away that effect, and that can lead to a lot of muscle atrophy, a lot of connective tissue atrophy, loss of bone density, and then a lot of issues in the cardiovascular system that make it very difficult to perform physically.
So it sounds like really the human body, the muscles and all the systems, contrary to me on the weekend sometimes, the human body does not want to lay on the couch all day and eat popcorn and watch television. The human body wants to have resistance and work and move, right? And how does that apply to something called micro tears, which I've heard about?
Well, like you were describing, it's kind of a use it or lose it situation. And when you're in space, it's a lose it proposition. And when you exercise, you actually create these little teeny tiny micro tears within the muscle and connective tissue, but your body goes into its recovery phase, its repair phase, and it builds new connective tissue and new muscle to help you be stronger. So the next time you put that load onto those muscles, you don't create as much damage. And that's why you have to continually kind of increase the amount of weight you're lifting and the intensity of the activity that you are doing.
Okay, so does that explain why especially if you haven't exercised in a while, once you start lifting weights, you are very sore?
Yeah, you definitely can be, and astronauts often experience that, especially back in the early days of the space program. When they came back to Earth, all of a sudden they were feeling these levels of soreness just from the effects of gravity.
And of course, in the movie Apollo 13, there's this scene where Tom Hanks' character, when he gets out of the capsule, he literally flops down. That is not all Hollywood. That is real truth.
Absolutely. When they, of course, were under a lot of stress during that trip. But there's also he gets out of that capsule, he's feeling the effects of gravity, and he's being pulled straight down because his muscles and connective tissue and bones were not as strong as they were when he went up into space.
Okay. All right. Right now, we're going to kind of turn this way so people can see these athletes behind us. Go ahead and tell us who these people are.
All right. These are all exercise science majors. And we have Abby Barrow, who is an outside hitter on the Saluki volleyball team. Next to her is Charlie Harris, and he is a safety on the Saluki football team. To his left is Megan Krolak. She's here from Saluki Cross Country and Track. She is a long-distance runner. And then last but not least, on the end, we have Matt Greenfield, who is a men's golfer.
Okay, let's go ahead and do the demonstration. We've got about...
We also have another one to introduce.
Goodness gracious! Holy... Woo! That scared the heck out of me. Lord Vader, is that it?
Yeah, from what I understand, Lord Vader is going to become an exercise science student this fall here at SIU, and so he wanted to come out here and demonstrate these exercises with us.
Sorry if I got a little carried away, but I had no idea that someone from the dark side is here. Wow. Could you get on that side? No, never mind. Okay, so we're going to do some exercises now.
Okay, the first thing we got to do when you do any exercise routine is you got to warm up the body. Now, we don't have all the fancy NASA equipment here, but you really don't need fancy equipment to get a good workout in. Now, the first thing we want to do is what we call warm up the launch pad. You'll notice all of these activities have a theme of a journey to and from space. So we got to warm up the launch pad first, because the launch pad of the body is your lower body, and it launches you into many different activities. So what we want to do is start with is just a march in place. So up and down, lift those knees as high as you can. Good. Excellent. Okay, we can stop that one. Next one we want to do is for the upper body. We got to warm up the upper body too. We're going to do an exercise that we call reach for the sun. Now remember, don't look at the sun yet, just reach for the sun. So the first thing we want to do is lift our left arm up in the air, bring that down, and bring your right arm up and down. And you guys at home can be doing these exercises with us, because you've probably been sitting watching the Eclipse coverage the entire day, so it's good to be active. Up and down. Good. Okay.
And I'm going to take a pass because I've been told I need to make sure and keep the microphone on you, so
okay,
I guess I'm going to be lazy.
That's fine. You're excused. All right, so we want to do a lower body resistance activity now that we call countdown to liftoff. So we're going to get our feet in a wide position, or we're going to do a squat, or we're going to count it down. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, liftoff. And one more time. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and lift off. Good. All right, now we got to do the upper body. And so I'm going to ask my athletes here to partner up, and I'm going to partner up with Lord Vader over here. So step over here, sir. Okay, so what we're going to do is an exercise that we're calling open the space capsule door, because you need upper body strength in order to open the space capsule door, because it's pretty heavy. So I want you to clasp hands with a partner. We're going to do an isometric activity where you're just going to be pushing against the other person. So push as hard as you can. Push, push. No, don't use the force. No, not fair. Don't use the force. Hey, good. It's kind of like a test of strength in professional wrestling. And stop. Good. All right. The only area that we haven't really worked out yet is the core. So all I want you to do is tighten up your abdominal muscles, and you're just going to bend forward. Okay? So bend forward, kind of like a standing crunch. You can do this sitting down as well. Make sure those abdominal muscles stay tight. And we're calling this exercise prep for reentry because you need a lot of core strength for the jostling that occurs during reentry. Last thing we want to do, we're back on Earth. It's called cool down after touchdown. All right, so all we're going to do is some nice deep breaths to cool ourselves down. So in and out, in and out, and in and out, in and out. And we're back on Earth. We're ready to roll.
All right, and we have just a few more minutes, a little bit more time, and thank you so much. You know what amazes me is, I'm sure you are aware, they just played a video. When we send people to Mars, that will be 10 months in zero gravity. People probably don't realize we had a wonderful video here at the stadium, and I'm not sure if our NASA Edge audience saw that, but there's exercise gear on the spacecraft, correct?
Yes, they have treadmills, they have exercise bikes that actually anchor you down so you feel the stress of that activity, and it actually does good for your muscles and connective tissue and bones, as well as your cardiovascular system. And they also have something that's called ARED, which is Advanced Resistive Exercise Device. And it's basically a machine that you can use to do bench press, squat, deadlifts, bicep curls, tricep press down. Anything that you can do in a gym for a normal workout, you can do using this ARED device, and you can do it in a relatively small space on the space station or on the spacecraft that will be heading to Mars at some point in the future.
And of course, we can't stress enough is the fact that the body, especially if I remember right, red blood cells are made in the bone marrow, and they need to have resistance to produce that. Can you kind of elaborate on that?
Yeah, absolutely. That's one of the things that'll happen in space if you don't continue to stimulate the cardiovascular system and stimulate that bone marrow, is that you're going to lose red blood cells. You're also going to lose blood volume and plasma volume. So your ability to deliver oxygen and nutrients to the tissues and get rid of waste gets compromised in a major way. And when you get back to Earth, it's very, very difficult to perform physically. Plus, extended space missions, you're going to have a hard time maintaining your physical performance and your mental performance because that's tied very, very closely with how in shape you are physically.
Because to think clearly and logically, the brain needs blood, the brain needs energy in the form of glucose and other sugars, right?
Absolutely, yeah. The nervous system uses carbohydrate almost exclusively as a fuel, so you need blood flow to be able to get to those areas in order to make them work right.
Tell you what, we've got just a few more minutes left. I would like to have one by one the athletes step up here, and I'm going to ask them what they thought about the Eclipse. Yeah, exactly. I did this on purpose, you know. This is not on the script. Give us your name and what you do here at SIU.
I'm Matt Greenfield. I finished golf last semester, so now I'm just trying to graduate.
Okay. And real briefly, what do you think of the Eclipse?
I think it's really cool just to be here because my family's back home in England, so they could see it over like the television. So it was really nice to kind of be here.
Thank you, Matt. And give us your name and what sport?
I'm Megan Krolick, and I run cross country and track.
What about the Eclipse?
I thought it was really cool. I was glad we got to see it, and I thought it was really cool.
Well, thank you for being here with us. What's your name and what do you play again, in case someone just tuning in?
My name is Charlie Harris, and I play safety for Southern Illinois.
What do you think of the Eclipse?
It was really unique, fun experience. Just being here, it was really special.
Thank you. Your name and what sport you play?
I'm Abby Barrow, and I play volleyball.
What do you think of the Eclipse?
I thought it was really cool. I thought the coolest part was just looking around at the light on everyone and then the sunset that was all around. That was my favorite part.
Thank you so much.
Thank you.
All right, and we're going to get Phil Anton back here. I do feel like maybe I should at least give Lord Darth Vader a chance to talk, but I don't want to talk to him without you around because you seem to have
He's having some issues with his voice communicator today, so I don't think you're going to get a whole lot out of him except for, like, you know, the use of the Force for nefarious purposes, that type of thing.
Well, in just a second, we're going to send it back. Thank you so much, Dr. Anton. I really appreciate it. Thank you for thank you for the athletes.
Absolutely. Thank you, Kevin. Appreciate it.
Here's a very cool video here on NASA Edge TV.
Just as early explorers had to endure weather as they traveled to new lands and explored new areas, astronauts, when they go on space travel outside the Earth's magnetic field, will have to endure space weather. This space weather would include things like galactic cosmic rays, which are